Doesn't matter. Thank you so much. It's perfect. Oh, I'm already on. Much better. So, does it work? I hope it does. Hello everyone, welcome to my session, The Path to Repeatable Builds. It did mention Docker in the schedule, so there will be some slides and some bits of story about Docker later, don't worry. Let's start with the basics. My name is Andrzej Grzesik. I know it's a bit hard to say and pronounce and spell, so I have a shorter Twitter handle. And those slides will be on SlideShare, and as far as I know, they will be put up and somehow synced with the YouTube channel for JavaOne. So you, of course, can take pictures, but you don't have to. A couple of facts about me. I come from Kraków, Poland, but I live in London. And I organize a conference called Geekon. I lead the Polish Java user group. I have been one of the founders of the software craftsmanship in Kraków. Founded Kraków Hadoop user group, so I've been involved in the community for a number of years and in a number of ways. And if you have Twitter, well, I know that JavaOne has a handle and they have a hashtag, and I also have a handle, so nothing boosts the ego like seeing tweets immediately after this talk. And there is an important note that I have to make. If you have any questions, try to wave your hand and attract my attention, because I will have, I have 3 sessions in a row today. So immediately after this one, I will have to run to the other hotel. So as much as I would love to have a long conversation in the corridor and argue till, well, probably till lunch, that will not be possible. So questions, try to raise your hands or approach me midday somewhere. I will be in the Hilton later. So to start with, something moralizing for the morning. It's a slide I really like, and it's what I try to apply to whatever I'm doing with computers. Sometimes when I'm doing something, it seems like a great idea, and you might have experienced that yourselves, and then it turns out that this great idea is so, well, there is a quick fix, there is a workaround, and I keep doing that, and I keep doing that, and it turns out that I'm doing this big ball, ugly, hairy ball of mud, and the idea is not really that good. And then if you multiply that not so great idea by results, it's not really different from a very bad idea from the start. So I try to ask for feedback, and I try to ask people if what I'm doing makes sense. So I would love to get your feedback after the talk, so please tweet. And a disclaimer, of course, for the legalist people from where I work. My opinions are my own. I'm not representing a company I work for. Sorry. So let's start. This talk is constructed, is made of a number of episodes. It's about the journey that I've went through with a number of companies, and some of the patterns, some of the things I observed around continuous delivery, around builds, around pipelines. So some of the things that I observed, some of the common themes and common patterns that some companies stop at, and then they are happy or less happy, and what can be done about that. The first one, I call it the new Jenkins. If you can see a reference to a popular movie, you're probably correct. What happens? A new department in a new company, and you probably have witnessed that a number of times. So what happens? Well, of course, developers come in. Everybody's so eager, so focused. So we'll do this code. This time it will be different. It will all be perfect. And 2 weeks later, usually, yeah, we'll need a Jenkins. So somebody will download Jenkins or TeamCity or, well, your favorite continuous integration tool. They'll try to set it up, probably on their own machine, because, well, that's where you start, and that's the easiest. And then you get this, at first, ad hoc manual Jenkins that somebody runs, and only if they are in the office, and that works. And that's there because, well, as I said, the department is new. You need to run the tests somewhere because you want to be making progress. After some time that happens, and what happened in the case of the last place I worked for, it was a development box turned CI, which also makes a lot of sense. The that desktop was very powerful. The caveat was that was a development desktop, so it was in the office. If somebody tripped on the cable, if somebody disconnected the cable, if somebody wanted to use that desktop, our Jenkins, our CI server was affected. So what happened later? That desktop was turned completely into a CI, so somebody didn't have a desktop. It worked. Of course, it worked while it worked, which means when it broke down, somebody had to fix it. Because that was a development desktop, you can expect that nobody was managing that system in a way that you would expect for a system to be managed. And then, of course, somebody had to fix it. First question becomes who fixes somebody's development desktop when that person is away? No, it's not me. I don't want to touch their computer. I don't want to touch their computer. It's not mine. I really don't know this flavor of Linux. I have no idea what to do on Windows. You probably have seen that before. So what happens? What ensues is magic, mysticism, problems and pain. It's gory. On a scale from 1 to 11, with 11 being reserved to absolute awesomeness, this gets a 1. Why does it get a 1? Because it's not repeatable, it doesn't scale. Yes, it gets you somewhere, but this is exactly as good as Jenkins hosted somewhere in the cloud, or Jenkins being run in a VM on your machine. And actually Jenkins being run on a VM on your machine has the benefit that you can share that VM with other people. So you can store it in a safe place, and when it goes badly, you can actually revert to a better place. If that's just a desktop that's running Jenkins, things will break. What happened in that case, we went from a desktop running Jenkins on its own to a box that would be running a virtual box with Jenkins. Why virtual box? Because it was the easiest thing to set up. What happened? That worked pretty well for quite some time until somebody upgraded the host. And then VirtualBox broke and we were without a CI for a couple of days. And then only one person wanted to be the person fixing that, because that involved some hacking around kernel configs, because that's what they found on Stack Overflow. Some other people would say, no, let's just get rid of whatever is there and reinstall it. No, it became a personal challenge to fix that desktop. So, as you can see, from a development team that needs a CI point of view, it's not really the most efficient way. From somebody wanting to play, yes, it's okay, but as I say, I would prefer to have a dedicated box, something that everybody looks up to, and not just somebody's under the desk. Of course, not to mention the cleaning stuff that sometimes want to water the plants, and then, of course, from time to time, not so often, but they do water the server or the computer that we have in the office, and then, moving on. Episode 2, Node Wars. As I said, I mentioned the cleaning people or just me being sloppy in the office and spilling coffee everywhere. Machines break. That's not a surprise. Of course, when that happens, everybody is surprised because, I know other machines break, but it never happens to my machine. My MacBook, my desktop is super. And it used to be the case for me, but this year I'm on my 6th MacBook Pro for a number of reasons. Machines never break for me until they start, or they never did, because now it's too late. Same happens to desktops, of course. So machines fail, and you need to do something when that happens. When a machine fails, you need to create another one. That's obvious. But also, you need to create more CIs when you have more builds, because when you have more builds that need to be happening and the resources are the constraint, then you just need more CPU power. How do you get that? Machines. If you're on Amazon or somewhere, you just click. If you're in in an office environment, you maybe not necessarily, you do click a bit, but you also have to reconnect some things. The problem that happens is you need to get those boxes into maybe not a shared state, but you need to install Jenkins. You need to install all the necessary things for all those servers. So to do that, we used not this chef. We started doing Chef, and Chef, for those who here has heard of Chef. half of the room, that's good. For the rest of you, it's a configuration management tool, so it allows you to express infrastructure and system configuration using code, so you don't have to write bash, you don't have to write, I think it's called PowerShell on Windows, but I don't touch Windows. I'm very proud of it. The thing is, it allows you to write some code and then apply it to a number of boxes, and that will get them to a state that you want them to be. Which means you can quickly spin up or have a number of Jenkins boxes and move on pretty fast and concentrate on development. So what happened there? Because we had a way to effectively break machines, people started feeling empowered to doing things to the VMs, to CI servers, to the software, which is good because, well, we are developers, we are change agents, we actually need change, we are paid for bringing change to organizations. Having a way to revert to a very safe state, even with something as important for a development team as the CI server, means it's okay to break stuff, it's okay to play because, well, in the worst case, I'll just click a button, wait a couple of minutes for Chef to execute, and then everything will be there. My machine will be in a state that I know, and from a development team having a CI point of view, it's absolutely awesome. Because if anything goes down, click, wait, you're there. If you need more boxes to run your builds, click, wait, you're there. So that situation, of course, was so good that a couple of other things had to happen. First of all, we started chefing our Jenkins server and our nodes, and that was awesome. First of all, because of Java and our typical development department, for mostly Java developers starting using Chef. So they started to learn about Linux, they started to learn about how you do system configuration. They started to learn, people love learning, at least I love learning. And that gave people the feeling of power. Now I'm the awesome, omnipotent developer who can not only do backends, they can do frontends with Angular, and I can also do servers. It feels good. Of course, you will later realize that you're not as experienced a system admin as you could be, but it still means that you actually can do something in that very space that probably some of us never touched. What happened also is we tried to go a bit too far in certain directions. So when all you have is a knife, or the knife that you're using is extremely comfortable, you're going to try to see how far can you push it. So for us, that meant trying to Chef configuration. So trying to generate Jenkins configuration, which is an XML file using Ruby templates and a lot of nested ugly for loops. It sounded like a good idea in the beginning. It felt like we are not exactly sure when we started doing that a bit into the task, and then it turned out to be an absolute nightmare. Unmaintainable piece of code that only we could fix, nothing on Stack Overflow. It's not that we need it, but it's a very useful thing to have Stack Overflow when you want, because, well, you can ask about Jenkins, you can ask about Chef, or you can find a lot of things, but not about the in-house tools, unfortunately. And that also meant that we effectively wasted time on things that we could have done in a different way. What we learned is probably it's the best way to configure Jenkins is ideally in the Jenkins UI or the command line, because that gives you the power to do, you know what to do there. You don't have to learn the templating language, you don't have to learn the configuration syntax, and that changes from plugin to plugin, so it's so much easier to do it in the UI. Also, speaking of configuration, because now we were running in a more distributed, bigger environment, we started thinking about backups. Backups turned out to be a problem. Because the first question is, how much do you want to back up? Is your build history important? Of course it is, because it's green. And you can see your, test coverage going up and steadily up and almost never failing, because we deleted the failed builds a number of times. And that was all good, but those builds, that build history can be heavy. And it turns out, in our case specifically, it turned out that we don't really care about that. The intuition that we followed immediately was, yes, let's back up absolutely everything. It turns out that backing up just the XML files, just the configs, was just enough. But as I say, this is a story of what we went through. Some of the decisions weren't exactly good. Coming back to the aspect of the environment being bigger, so we had a master Jenkins, we had a number of slaves, and obviously as some of those nodes are sitting on some boxes somewhere in some cloud, we started thinking about monitoring. Yeah, because that's what you do to systems. You monitor them, you analyze them, you want to be alerted if something goes down, and you want to have some pretty graphs that will show you the CPU usage. Oh, there is a build kicking in. Yes, we can see that from the red on the CPU usage. And monitoring nodes, yes, they should be there when we need them, but it turned out to be another yak shaving activity, because yes, it's a Jenkins thing. It's development tooling, and you don't really need it to be highly available and replicated and everything, because that was again pushing the knife that we felt so comfortable with a bit too far. On my ranking scale, this approach of running it with Chef and doing infrastructure to your CI gets an 8 out of 11. Because learning how to do infrastructure was extremely valuable. It helped a lot, and that's a skill that was used and applied later in many cases. In terms of just the CI, do the minimum or do the medium average amount, and then let's just move on. Because having a highly available Jenkins installation is not really that needed. Allowing Jenkins just to spin up instances as it needs from configured images, that's just fine. We don't need those nodes all the time. Of course, we had to learn that, so that took quite some time, a number of months. But well, this is a story of what we did good and bad. So, episode 3. What happened? Why do I call it Revenge of the VMs? So we've had our beautiful Jenkins installation. We've had our beautiful software written. It was all Java and Scala, so much win. It turns out not really, because there came a bit of software that unfortunately happened to run only on Windows. And what do you do to pieces of software that run on Windows? Well, what we did was we tried to put it into a VM, contain the damage, and move on. Why do I say contain the damage? It's not that the software is bad because it's running on Windows. No, there are certain pieces of software that don't really support automation, and they are just not development friendly. Because if you want to install them, you need to click, you need to activate, you need to enter a serial number. Not even to mention dealing with corporate license management, because when you have a number of Windows installations, who activates them, who does what there, if you're not covered by a blanket license, or if your use case makes people who are taking care of the blanket license for Windows a bit uncertain, those discussions get funny. For us, being developers, licenses are very important, but what hurt us on a daily basis was software just didn't like to be automated. It didn't like to be touched. We just needed it to be up there. What we did is we made a VM, we made a sacrifice. We spent 2 long and painful days. We treasured the image after the software was configured, and then we were running it from a snapshot every single day. Of course, the image was stored in a number of places, and nobody wanted to touch that because, well, that's just normal. And that was a very, yeah, there is a question.
Sorry, what does treasure the image mean?
Treasure the image as in store it in a very safe place and make sure that it's safe and so that's like a treasure. Okay. We didn't hide it on an island and marked it with the X because we needed to work with that. But that's morally very close, because you don't want to go and log into that image and change too much because, well, you don't need to. But on the other hand, it sometimes when the software that we depended on was upgraded, we needed to integrate the upgrades, and then, of course, precious treasure, let's do it properly, let's not break anything, let's move on to our Java Scala comfortable environment. Moving on, mobile. Why do I mention mobile? Who here has anything to do with something touching mobile development? Yeah, so I used to work for eBay. The thing about eBay is, well, eBay in their development efforts are certainly taking and pushing for a mobile-first approach. What that means is when you're doing stuff on mobile, and I'm not only meaning mobile as in native mobile, there is a lot of mobile web. You need to test it. And if you need to test, you probably want that to be automated, because humans scale only that well. The tool that we were using was iOS Selenium driver. Anybody heard of that? Yeah, a couple of people. I had the pleasure of working with Francois, and what we were doing is we wanted to create a farm that would automate testing on iOS. That was a lot of fun. It turns out everybody in the industry trying to do automation for OS X uses Mac Minis because of OS X and virtualization licensing limitations, because you're only allowed to run two instances of the system on that. So Mac Mini gave us the biggest amount of bang for the buck. What it also means that Mac Minis will, they have to sit somewhere. Because we were using 32 Mac Minis, which translates into 64 VMs, we needed them to be put into a data center, and then that's a bit of a funny discussion. Dear data center people, we would like to put something in there. Sure. How many racks do you need? We don't know. What's the hardware? Oh, it's Mac Minis. Surely you're crazy. No, no. There are attachments. There are shelves. It's Mac Minis are data center kind of friendly, or averagely friendly. Well, it can be done. It's what a lot of people. It's what a lot of people actually do, because you want those machines far away from you, because you don't want to be knocking them over, watering, tripping, and so on. You want them well cooled, and when you get 32 machines, they also create a bit of noise. But you have the machines, you want to automate them, you want to do something with them, so obviously that has to happen remotely. First of all, how do you configure an OS X to be able to run Selenium in an automated way with your iOS things? It turns out you can do Chef server there. That's what we did. Then we started using Logstash to collect and analyze the logs from there, and it was all powered with VMware, because we were very happy using vSphere. That's what we did. That worked. What was funny? OS X is full of quirks. OS X is not your typical Linux installation, and trying to automate that is funny, because sometimes what you get is a pop-up. And going around the pop-up so that your tests can still work is sometimes tricky, unfortunately. So there was a bit of hackery involved. Well, there was serious hackery involved at times. We needed to be able to rebuild nodes, so the OS X virtual machines very, very quickly, as soon as we needed them, or as soon as they corrupted themselves, because they also started to express this, to have this feature that they would rot for some reason. On the large scale of things, the whole cluster was 64 VMs that worked, and is still working, at least to my knowledge, very well. The automation that we put in place, that when machine stops working, we just use the APIs for vSphere and then reboot it, put in the image, patch it, run Chef against it. That works all good. The problem is, yes, you need somebody that is knowledgeable about OS X and automating OS X, somebody who likes to hack with it, because it's a different system to what I spend most of my times with, and it has quirks. Sometimes you need to reach out to Apple developers. Sometimes that's very, very, very difficult, because they don't want to give an answer using traceable channels, so they don't want to give you a plain and a straight email back. You have to find somebody and then get connected and then meet them for a cafe, and then unfortunately, yes, because from an outsider point of view, Apple turns out to be a very secretive company about everything that's not public in their docs. So sometimes there is a lot of time that is being spent. And if you're testing mobile, you will need to test iOS, of course, so probably that's something that you will go through. But the good part is iOS on OS X works quite well. And since we had so many nodes, And since we had software that had to run mobile web, and since we had software that had some other dependencies, I mentioned the Windows boxes, somebody at one place, and it wasn't it wasn't at eBay. It was the pattern. The pattern repeats. That's what I call the bad idea of the century when it comes to trying to testing software. It's called X in a box. And I don't mean, it's nothing to do with Xbox. It's X in a box as in your whole production environment on a single box. Databases, Mongos, Cassandras, Service A, Service B, Service C, Service D, everything in a single box so that I can ship the box to you and then you can test your software and do integration testing. Well, you have our system running here, so if you need to do anything, it's quite easy. And it starts innocent. Because as you know, software and modules and testing dependencies is sometimes it gets very hard and very complex. You can try to put the things together. It seems like a great idea because all the dependencies turn out to be in one place. It's easy to do integration testing. It's easy to do, let's say, performance testing because everything is on this box that we have under your desk. It's easy to deploy my stuff because the other stuff doesn't change. And yes, it's just, well, the problems that you will get are exactly like not doing continuous integration. So when you integrate code late, the other pieces of software have already moved forward. You know the pains. We know those pains very, very well. That's why everybody loves Git. That's why everybody loves having a CI server. That's why we want to run tests very often on the most recent up-to-date version of the code base. Same rules apply to dependencies because, well, code compiled or everything else compiled, yes, things will break a bit, but why do I mention this as the worst idea of the century? So imagine you're putting some spaghetti, some modules, at least, well, your software, I can bet it must be better, but the software I sometimes work with is a bit like spaghetti, and it's not about the sauce. You put that into a box. Yeah, box is happy, yeah, nom 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 nom, that was a very delicious spaghetti. And time goes on, people keep working, and then it turns out that the spaghetti doesn't fit into the box anymore. Okay, well, what do you do then? It's quite easy. You go to Dell or your other favorite hardware vendor, you order a bigger server. And we have a bigger server now, so we can put even more spaghetti, and then, well, again, that will not end with a fat cat picture. That will just end with a very big, powerful box. And it seems like a great thing to have because we have this almost 100,000 box of having all of our environment just under our team's desk. And then you can multiply it by the number of teams that you have in the company. And yes, it will cost a bit, but actually this is not the biggest problem. What you get from this approach is, first of all, everybody sees that there is so much space left on the device, so much CPU cycles that go wasted, so we don't really have to worry. And yes, I'm talking about the system that does nothing because it doesn't get any real traffic, but the box is so powerful because to get something that can run your whole production, and we're talking a whole production of a reasonably sized enterprise, it needs to be a powerful box. So performance, not a problem. Threads, they come for free. RAM, we have a lot, like really, really a lot. What happens is you get a dependency spaghetti because you don't get to pay the network cost. You don't get to pay you don't have to look for how much disk space there is. What happened in that very case was software which, let's say, used 20 gigs altogether in the beginning ended up easily beyond 400 gigs. Or everything together because people didn't have to pay attention because the resources seemed to be free. And that was painful. The place that did that, to my knowledge, still hasn't untangled, just removed it, untangled this whole mess. It's still there. There are companies, some of them in or around Silicon Valley, in which you can mention the name of the company in a box, and people will cringe. You can probably test that during JavaOne because we have so many people from so many places. So you can, where do you work? And this in a box? Ah, no, okay. But anyway, I'm managing. But if somebody cringes, I know, you know. Again, Dependency testing, it seems like a good idea, but it's not, because you don't get the isolation. You get strange effects, you get really strange effects because, let's say, the database decides to do something, and because it's sitting on a single box, it's not isolated. Strange things start to happen, so people start making strange assumptions. And then if you try to imagine having a Jenkins connected to that sea of services, it becomes really, really difficult. First of all, because to be able to run tests in a reasonable manner, you would like to start from a known state. To reboot your whole company or half of your company's system, well, I know what to do to my applications, but what about those dozen or couple dozen of other applications? This is not maintainable. So your tests start to degrade. Your tests start to degrade in terms of performance, in terms of what they test. You get false positives, you get false negatives, because there are interactions, there are races, there are just interactions that you couldn't have foreseen, because all strange things happen. The team that is being made responsible for maintaining and provisioning those boxes, because sometime you make a release and then you have to reinstall everything on that box, and you have to multiply it by the number of teams, and then because this will become an error-prone process, you will say that, yeah, we'll give you 3 boxes and we'll hope one of them will work. And again, expensive boxes times the number of teams. This is getting into serious money. Don't do it. Just don't do it. Don't go this way. There are better ways. There are simpler ways. Test your software well in isolation rather than testing everything all together. Moving on. Finally, some Docker. Since some people seem to be asleep because it's morning or you enjoyed yourselves yesterday, who here uses Docker already? Okay. So Docker for the rest of people, since you're not using that, from mine experience and our experience at eBay and in different places, it does break a bit sometimes. Not too seriously. It's absolutely amazing for hacking. It's amazing for productivity. It's amazing for development. That's where we started. That's where we immediately fell in love, because it's so much lighter. We used to be using vagrants and virtual machines a lot, and Docker so much better. So good. So great. We're on a Java conference, so there is a caveat. Just installing a JVM, getting a Docker image that supports Java is nothing really that difficult. It's a very well understood process. The caveat happens when you have to do Maven or SBT, because you need to get the dependencies. And of course, you can try to put the dependencies onto the Docker image, and then the Docker image will be fat, because, well, Maven needs things, if only to delete a directory, not to mention just building some software. So a similar problem is, well, connected with SBT, because it has to resolve the transitive dependencies. So you need the bin utils of the bin utils of the digester of the bin utils. The solution, of course, is to use images. We started with clean Java images. We then ran the build, threw away the target directory. I heard some noises. Those were funny noises, and they made me smile. They made other people smile. If you have some more cool music, I can borrow the microphone for a moment. So anyway, coming back to the Docker and images and dependencies problem, or libraries. We started doing clean builds, so something equivalent to, let's get a fresh Docker image with Java, let's do a Maven and clean install in there. If it all passes, let's throw it all away. That's wasting a lot of disk space, a lot of time, and a lot of time. Because Maven and or SBT or anything like that has to resolve a lot of dependencies, and every time you recompile, you lose a lot of time. So that's why I really wanted to stress it out. So what we started doing is we did run a build. We throw away the compilation product just to have an initial Maven installation. And yes, we created an image out of that just to save ourselves some time. And then the amount of time lost was so much better, as in smaller, not larger, because that's what better means in that case for me. And we were very comfortable. The important bit why we went this way is VMs. You tend to keep them. You don't want to be starting VMs from scratch every single time, because it takes a couple of at least seconds to boot a VM. In our cases, it was more like minutes. So Docker, running the build almost instantly and being done within a minute. So good. another nice thing is from within a Docker container, you get to interact with the Docker daemon, and you can do it using REST services. So there are libraries even in Java that allow you to do that, or you can do it on your own if you prefer. Which means if you have a distributed system and you just want to spin some dependencies, remember the big big fat server story. Don't do everything. Just the immediate dependencies that you have, and do some limited interaction testing. We could do that, and we did that, and that was Docker allowed that in a very, very easy way. What happened almost immediately later was we got into a place in which I call developers doing infrastructure. What do I mean by that is not that it's bad for developers to do infrastructure. No, that's great that people are interested and people want to learn. And the thing is, if you're a person who spends majority of time doing Spring, doing Go, doing Scala, doing Akka, pick your favorite technology, and then you try to configure something on the infrastructure side. If you succeed early, well, you will get this impression that it's actually quite easy. And sometimes, yes, it is quite easy, but Linux as a whole thing, or a production environment as a whole thing, is a huge thing. There is a reason why software administrators are also paid very well, or they should be. It's because, well, there is a lot of knowledge that they have to, a lot of good practices that they have to be up to date. Same as we have to catch up with Java, with all the libraries, with all the specs. Maybe not EJB tools anymore, but they have to do the same. The problem what we had was we have a Docker. Well, we have this Docker that we run for testing. We want to ship it into production, and then it turns out that production doesn't really support it the way we want to. Because our Docker doesn't do X, our Docker doesn't do Y, our Docker, I don't know, doesn't care about upgrade, security, logging, monitoring, all the things that you would normally have. And there are two ways in which you can do it now. You can, well, the developers can start learning about it, or you can start looking at different teams, because there are probably teams in the company that already are responsible for making sure that software runs in a reasonable state and is being monitored and looked and cared for. And that's, in our case, that was the solution. So when you have multiple teams and you want to use Docker, we had to find a way to make it work. So at first we started publishing Docker files, and then people would append to the Docker files, and we tried to go through a grand unified Docker file for everybody. That went nowhere. For those of you who don't know, the Docker file is an equivalent of a build file for a Docker image. So a build file for your VM, but in Docker terms, Docker file. We tried doing that. It didn't really work because people needed to change text, and sharing that with people who have different approaches to source control doesn't happen. What worked much better is, first of all, multiple teams. So there would be the platform team, the production environment team that would create a base Docker image that we would then be allowed to install and configure our software on top of. And that worked pretty well, because that meant you get something that's certified, that's trusted, that's well understood, that they are very happy that you're using, because you're using their work. And on top of that, you get to install your Ruby, your Java, your Scala, whatever that is. And then, well, they get to see that, because the amount of changes that they have it's from a well-known state that they created and they're just examining the changes that you've created in there. And another good thing is probably you're not the only people who are doing that in the company. So for them, it's much easier thing to understand. For you, it's much easier thing to understand, because you don't have to understand everything that happened before. We effectively went to a story very similar to running things with VMs, with many VMs, but just on Docker. And because you can spin up Docker on this very box, and I can do it on other boxes, that was a great idea. The caveat was, well, the idea pushed a bit too far. We didn't go that far, but the temptation was in the air. You could clearly feel it. Container, all the things. We did have Cassandra in a container. We did have a database in a container. We did have something else in the container, and then somebody mentioned maybe we should put that other set of services into a container. And then somebody said, wait, because we're starting to become this monstrous monster. There is a caveat, because it's so easy. sometimes you have to take a step back, and with Docker, because it's so easy, it's important not to try to instantiate and launch absolutely everything at once. For the reasons that we discussed with the big ball of absolutely everything, because it's so easy, it's tempting, then software, having some isolation is good. And also some more quirks. Some developers, myself included, love OS X because it gives a decent desktop experience while looking decently, while pretending to be a Linux. It works. The thing is, you can't run Docker daemon directly onto OS X, which means you get into things like boot to Docker some time ago, or Docker machines, which means sometimes the Docker machines will explode. Which means that for those of you who are not familiar with boot to Docker or Docker machine, because OS X will not run Docker natively, what you do is you run a VM using VirtualBox usually, that will provide the Docker environment for you to run your Docker containers in. So you're not running that on that directly, but you're running inside a VM. And when you create a VM, of course, you have to allocate some CPU, some memory, and some disk. And as you do more and more containers, that VM sometimes can go down. What you learn while doing that is having a corporate image repository is an extremely important place. It doesn't have to be corporate wide, but it's just, if you're doing anything serious with Docker, you have to have a repository. Dependencies and orchestration. Yes, if you have software that is convoluted, you will have dependencies, and you will want to orchestrate them because you will want to start different things at different times. How can you do it? Well, we did use the REST API, and we were super happy with that. I wholeheartedly recommend that. And the last great thing is, Jenkins, at least from my experience, can use Docker to run the test, and that works well. But what works even better is having a starting point inside your test that will spin up whatever is needed, and so that you expose the Docker handle to your tests. And the question is, of course, where should you take it further? Where should you now take it to? And that's a question I don't really have an answer for, because this is about the steps that I and the teams I work with went through. I can't see into the future. I'd love to. So if you have any questions, just wave your hands, and I'll try to repeat the question and then answer it. Yes?
I had a question about Docker. So what was the learning curve for learning Docker versus the time it took to develop that culture for how to use it?
So the question is what about the learning curve of Docker, and how much time it took us to actually learn to be productive. There was almost no learning curve. This is a department in which half of the people actually learned how to do Chef, easier or slower or faster, and Docker was so much easier. So the learning curve, I would say, in 2 weeks we felt confident with technology, and I'm meaning 2 weeks because some people were on holiday, somebody goes sick, somebody's busy. But in 2 weeks we were okay to get into a steady workflow, to be able to say how we should work in a distributed team fashion. That took us 2 months altogether, and the process that we have created was decent. We felt quite happy. Of course, it's not all over because Docker wasn't in production at that place. So yes, there will be changes because of the rest of the company that will impose that. We did have to reach out to the platform team so that they would be happy with us using Docker images that they would provide. So they needed to start to provide them. But if you ask admins or admin-like or platform kind of people to create Docker images, that's just, yeah, of course, have it. It's like our VMs, but in a Docker. That wasn't a huge deal. Of course, the important to have there is mentality. I had the pleasure of working with people with which that wasn't a problem. So I'd say 2 weeks to get developers is nothing unheard of, and then a couple of months to get everybody on the same page. But it's super easy, it's super fast, and the immediate selling point of being able to run a container just like that and not having to wait a couple of minutes to spin up a VM is a great selling point. There is a question on the left, yeah?
Around between Puppet and Docker.
Uh-huh.
Trying to see if there are any.
So the question is if there are any differences, or what I would say what the differences are between Puppet and Docker, right? So Puppet and Docker are completely different technologies. They are they are orthogonal. Puppet is a configuration management tool. This is a tool that you use to deploy changes to systems. So if you need to install Apache, if you need to configure Apache, yes, please use Puppet. If you want to create users on systems, yes, use Puppet. If you have a large fleet of servers, please use Puppet. Same goes for Chef, same goes for Ansible, same goes for, well, configuration management kinds of tools. Docker, as a technology, is a container. Well, Docker is a container technology, which means what they try to do is they will allow you to run containers. How you prepare them is your choice. You can, of course, use Puppet. You can, of course, use Bash. You can use Chef. You can do whatever you want there. But we started with Chef because we started with doing Chef before, and it turned out that we had to do less Chef when we were doing Docker. So we had to configure them less, or the configuration steps were so much simpler, because that usually was just applying a couple of commands to an existing image. So did I answer your question?
Yes.
Okay, thanks.
We already have Puppet, and
I think, well, I'd love to have continue this conversation over in the corridor, but I will have to run immediately after this finishes. Anybody else? Yeah, there is a, on the right.
Is there any difference between Windows running Docker in Windows or Unix?
Is there a difference in Windows running Docker and Linux and Unix? Yes, if you're on Windows, you have the same story as, at least to my knowledge. You have the same story as with OS X. You have to use a Docker wrapper, so boot to Docker or now Docker machine, because when I last checked, you couldn't run Docker images natively on Windows. So you needed that Linux component, Linux runtime somewhere, so that effectively meant you needed a VM that would run the image for you.
But when it's done,
Does it run smooth? Yes, it probably does. But I would expect there are mature virtualization tools available on Windows. But as I was stressing a couple of times, I don't have a lot of experience with Windows because I focus on environments that use Linux, so some sort of Linux for production. Did I answer your question? Awesome. Yep.
Sorry, I didn't really understand how you said you got around the problem with Maven dependencies making the image really sharp.
The problem with Maven dependencies and Docker. So the problem, if you were sleeping, is when you get a clean image that only has Java, you put Maven in there. When you first run Maven, it tries to download the internet. That's what Maven is and will eternally be famous for. What we did is we had a clean install of a system. Then we would run that Maven with a set of different flags. So including site because it downloads a lot of different dependencies, the dependency sources, and so on and so on. And then we would package the M2 repository into the image. That was step one. And then what developers did on their desktops was instead of running on top of that image, which was quite fat because of the jars, we started playing with just exposing your own Maven repository to the Docker image, so that the Docker image would talk to your Maven repository, so that would be effectively whatever you were using as a developer. And that for development was obviously, it worked extremely well, especially if you had a number of snapshot dependencies, because then you didn't have to go all the way to publish it to an Access or publish it to an Artifactory or your tool of choice. On the other hand, the caveat was you can't really, it's not a solution that's sustainable when you are publishing software, because I might have my snapshots on my desktop, but if I don't want to push them, how is let's say Chris or Paul going to use that? That's not so. That's why we had a way to put them into the image as well.
So for release builds, you're using that?
For release builds, we only did release jars. We don't want to keep snapshots lying around because that's just bad. If you want to release a jar, release a jar, and then that's when it becomes public to everybody else.
Okay, so you would use that bigger image with all the dependencies?
Yes, we would try to save time.
Okay.
There was a question in the back, yeah? Can you come closer because I can barely hear you?
You're considering to create like the Docker images when new developer joins.
Uh-huh.
And I want to know if this is a valid use case. So what we are thinking is we create a Docker image from what stable version of our software is, give it to the developers who newly join, and then they work on the source code and then deploy to the Docker image. So because because the environment is very complex.
Uh-huh.
Thinking like, is that something we can do, or it's
Yes. So the question is, if you can solve a problem of new people joining teams working already on already complex software by putting the complexity into the Docker image and giving that to the new developer, so then the source code changes can easily be added on top of that. And yes, logically it would make sense, but from what you're describing, it seems that the problem that you have is in the complexity. So I would try to instead of introducing another tool into the mix, or using Docker as an interim solution, I would try to tackle the complexity so that it would effectively be easier. Because yes, you can orchestrate around the complexity and you can try to build fancy things around that. But what the problem that you're having is, as you said, is the complexity. That's what you want to get rid of in the first place.
There are a lot of steps to actually get the environment working.
If there is a lot of steps, then you can probably put that into a script. And then if that's just a number of steps, if you have them in a script or if you have them in a Docker file, I wouldn't object immediately, because scripts are best done in by machine. I get bored easily, and I would expect you to have very smart developers who also get bored. And also, I make mistakes when I do, because I can mix commands up. So putting that complexity into Docker image sounds like a good idea, without knowing too many details. So, is there? Yeah.
What is your view on, in our setup, we deploy VMs.
Mm-hmm.
That's first in production. But I like the idea of being able to do dev tests and those kinds of things more efficiently, potentially using Docker. When you're not testing things that are impacted by the OS, do you see a negative to that approach?
So replacing, the question is, do I see any problem with putting my runtime into a Docker image effectively versus running inside a VM for testing?
Really, it's keeping the production and implementation on VMs, but trying to speed up the development process.
So using Dockers to run tests immediately, and then having the big fat tests later using VMs. This is exactly what we did. We at eBay, the software we were doing was targeting VMs, and in development we started doing Docker images and running our tests from containers. First of all, because you get a fresh container every time. Second, because it's so fast. Because we as developers, at first, when you're writing software, when you're coding, you want a very quick cycle. So Docker gave us that quick cycle, and then yes, the integration test sometime later, we would push Docker up to the integration changes, and integration changes would then happy with the big fat beefy, if you will, VMs powering them. And yes, there are some differences, but that depends on your software whether you will be impacted. If you're just a web service, or if you're just a web application or a backend that talks to a Cassandra or something, that's not a big deal. If you have native code running somewhere, that depends on what your native code does. So I would expect 75% of the software would just benefit from having a way to quickly run your tests in isolation. You might, of course, fall in that specific category in which you might observe some differences, but that depends on your software. One caveat in which I wouldn't immediately recommend it is there will be performance differences between running software inside the Docker container and a VM. And if your software is very critical about the performance, that would need a more thorough and serious discussion.
Great, thank you.
Yeah. So just to set some context, there are 7 minutes left. How many questions do we still have in the room? Can you just one, just two? Okay, 2 questions, and then I'll need to go. Sure, go ahead. Can you come closer, because your voice is not. Come closer, because I will not be able to hear you.
How can we use Docker for quicker development? Like right now we are using this traditional development, like you do the code changes in the Java and then directly deploy on the application server. But if it is a Docker, our application server is inside the Docker, and
Dockers and
how to rebuild the Docker image and put it and then run it. Then isn't it a tedious process? Like every time, if you
okay,
do
so
one line of code change and then you.
So the question is, how do you use Docker with an application server, and if you change something into the application, how do you avoid rebuilding everything? I would. My personal context is I happen to be lucky enough not to have to work with too many application servers now. actually since the past couple of years. But what I would try to do is I would try to create a base image in which would expect the source code to be in a directory inside Docker, and then you would the products of your compilation, you would just put them into the directory. So are you using Tomcat or some? Yeah, so if you're using Tomcat, the directory to which you would put the web application, just connect that to your, let's say, local file system, or use that as the integration point. Have everything Tomcat already in the image, but then put the products of your compilation in there and then spin it up this way. That should be not even. Yes, code would be code would be outside of the image, and then you would merge the base image that already has Tomcat, Java, and everything else needed with the products of the compilation. That should give you a decent development cycle. And if you need more details, send me an email, tweet to me. I'll be very happy to continue that over, because there is one more question and we only have a couple of minutes.
So the question I have is really, why exactly are you guys actually doing the build inside the Docker? Like, why aren't you doing the build outside, with Maven and everything, and then just taking the artifact and then deploying that to Docker?
That's an awesome question. The question is, why are we doing the build inside the Docker, and why not do the build traditionally and then publish the products into a container? The first reason is repeatability. Because with using Docker, what we get is we start from scratch. We start the same container every single time, which means the only things that changes is the application code. Second thing, it's trivial to set up a new environment for anybody who joins the team, because what they need is access to the Docker repository. They are able to, if they can run SBT and they can run Docker, they can run our tests. All the complexity, for example, Cassandra. Our software relied on Cassandra, so we were spinning up a Cassandra image. And of course, yes, I can ask somebody, can you please go to Apache or do homebrew, install Cassandra, or I have no idea what you do on Windows, but there must be something like that. Yeah, of course I can, but why? With Docker, those problems go away. And everybody in the team gets the very same experience. So you lose the problems, you lose the differences in the machines that would sometimes give you false positives or false negatives, because everybody runs the same set of tests. Which also means that if the tests pass on your desktop, and this is actually what we have observed, is we stopped having tests surprisingly failing on the CI server because of differences, because you effectively are running the same code, the same environment, which you don't play with that much, and that was a huge win. Because if there is a number of components changing at the same time, of course, sometimes, at least my development desktops sometimes get polluted with things that I don't expect to be. Some things are lying around, some things I'm changing the name of a file, and then I'm doing a git stash or trying to revert, and I'm in the middle of something, and then I decide, just forget about it and compile something, and Docker takes that away. Problems that are happening because of that reason, they didn't happen for us, specifically because we were using Docker and we were starting from a clean plate every single time. Thank you very much for your attention. And I would really, if you have any more questions later, send me a tweet. Please press the green button, the green duke, as you exit. Then I'll get to see some numbers that you actually enjoyed. I'm really happy that you woke up so early to be here on time and spend the hour with me. Thanks. And also, if you're interested in the next session I'm doing, it's in the Hilton in Imperial Ballroom B, and I don't remember what topic is that is about. Thanks.
Testing, testing. Good. Thank you. Couple minutes, please. Oh, maybe not. Doors closed. It's not trip over the cable. Cool, nice one. Can everyone hear me? Is that all right? Yes. I'm conscious. Great. Conscious. Is this going to? As I.
Yeah, it's causing a little. I can pull it down and we'll just use the mic on the podium. Is that your way of getting the lapel?
Yeah, tricky, isn't it? So, I don't know. Like, should we go with this?
If it's making too much noise, I can pull it down.
Cool. Should we go? Is everyone okay? We'll try with the mic here. If it creates too much like bumping around, just like nod and we'll swap over. But that's good. I'll try not to move around too much in the video as well. So welcome everyone. So this is the building a Microsoft ecosystem, some assembly still required. What I'm planning to do today is first off define what I'm talking about with a microservice platform, ecosystem. Look at how the local development of services can be quite tricky. Thinking about some build pipeline stuff, how you get your services into production, how testing requires a bit of a paradigm shift with the microservice world, considering infrastructure and then planning for the inevitable things that go wrong as well. So I am a consultant over in the UK. I work for a company called Over in Credo. We do sort of everything from greenfield initiatives. We help our clients transform businesses, both from digital and business point of view. I love Java. I am a Java developer by trade. A bit of Golang of late. I've also moved more towards the ops side over the last few years. So DevOps, for want of a better word. But DevOps, I know there's culture and tooling and a whole bunch of other stuff, but I really enjoy that kind of thing. And of course, microservices, cloud, and containers. A lot of our clients are interested in these things, so I've kind of gravitated to that as well. And I've really enjoyed what I've learned, actually. Just did a session previously on Docker, so I shared some of my learnings, so you can get the slides for those later on as well. I'm also the maintainer of Moo Services Weekly. It's a microservice weekly newsletter. Started it about a month ago, and I send out every week a lot of interesting articles around microservices. So please do sign up at Moo Services Weekly. I tweet some stuff there later on. We're getting good feedback so far, and it's a community thing. So I'd love for more of you to send me stuff that you think is cool in relation to microservices and developing them, and we'll share the knowledge, which I'm really keen to do. I am one of the Jug leaders in the OJC, London. I do a bit of Adopt OpenJDK stuff, not too much of late if I'm honest, I've been busy with other things. And I'm an InfoQ editor, write for DZone and Vox. Again, I just love learning and I love sharing it, so always happy to get your feedback on these kind of things. So let's start at the very start. What is a microservice? Like, who is using microservices, sort of playing around with them? Not that many. Well, 10%, 20%, that's great. Who's using microservices, say, in production? Great, so you guys, I'm not sure what you're doing here. No, I'm joking. As in, like, we'll share some techniques, but I'm going to start at the basics and work my way up. Yeah, so some of the stuff you've got in production might not have been used to you, but I'm hoping there'll be something you can take away. If you're new to microservices, I'm hoping you take away quite a bit. That's the idea. So microservices, loosely coupled service-oriented architecture. Adrian Cockcroft at Netflix fame. I like that definition. It is kind of classical SOA-inspired stuff. There's a lot of bad stuff with classical SOA, a lot of good stuff as well. And we're kind of mixing in this domain-driven design concept of bounding context. I'm not going to talk lots on that, but fundamentally it's about applications that fit in your head. James Lewis, ThoughtWorks, great guy over in London, he talks about if you can understand an application, if you can poke something and see what happens here, that's a microservice. Yeah? Our classic monoliths, we poke something and like some stuff happens and something drops over here. They're just too big to comprehend at times. What I'm going to look at today is about building, testing, deploying, operating, and observing microservices, albeit within an hour. Yes, there's only so much I can cover. I'm really conscious that there's a lot of microservice talks this year, so I'm sure you've been probably been to a few already, and I'm quite keen for you to get out of this session what you'd like to get out. So I'm happy if you want to ask questions as we go along, just share it for my attention or whatever. We can try and develop to the session if necessary, addressing certain bits. If your comment is very specific, I might move on and look at, have a chat to you later or something. But in general, I'm quite keen to steer the presentation as you'd like. So in terms of a platform, if we're building microservices, what is a platform? And Adrian Cockcroft, again, loving this stuff. He talks about having a development language and container, orchestration platform, data stores. You obviously need tooling, you need configuration, discovery, routing, observability. This is becoming what a microservice platform entails. It's a bit different than a classic monolithic platform where you have your WebSphere, you have your Jetty or whatever, and you just put stuff on. You need other things because it's a distributed system, fundamentally, even if it's not distributed over the wire. Alexis Richardson from RabbitMQ fame kind of coming to the same conclusions, yeah, which is good to see. A lot of people in the industry, they've been doing this stuff, they're kind of the leading edge of stuff, they're coming to the same conclusions, which for people like us is great. It means there's some places we can standardise on, and where you can standardise, and that's a good thing. It's easier to do, and there's less kind of not invented here syndrome. One interesting thing with Lecture Richardson, he talks about continuous integration and continuous delivery being an essential part of microservices, and I think it really is essential. One final reference, Joe Bader from Google, I think he's ex-Google now actually, talks about the anatomy of a modern production stack. Great read, recommend if you read later on. It's a very different stack than a traditional stack, traditional bare metal or VM type stack. And he makes some really good points. There's a lot of tech basically involved at the moment. Microservices, Docker, containers, it's all emerging. And where things are emerging, there's a lot of development, both from a business and a technical point of view. And it can lead to quite a lot of choice. Docker, Rocket, LXD, CoreOS. This is not my slide, I've borrowed this from Wikibon, but there is a heck of a lot of choice just in like the container microservice tech space. And it pretty much leads me to this. It's just overwhelming, the sheer volume of tech stuff we can look at. If you are going to develop a microservice platform though, you do I think need to set up some core decisions up front. You can go towards platform as a service, Cloud Foundry, Amazon, right down to DIY stuff. But you're going to need to do a lot more stuff when you get to the bottom here. Does that make sense? Cloud Foundry, very opinionated, but you literally can drop in your app and you're good to go. Building your own thing, full control, full power, but you're going to have to do a lot of the hard work yourself. Packaging is also a key thing. Do we want to package our apps as services, tasks, jobs? Do we want to build pack them? If you're used to Cloud Foundry, build packing is very nice. HashiCorp and Otto, they're bringing this build pack thing back a bit. A build pack is essentially, you have an application, you just bundle it and you ship it to somewhere, and they figure out how to run it. They recognise it's a Java app, they recognise it's a Ruby app, and they run it according to the current best practice. So HashiCorp are looking at doing that, definitely Cloud Foundry does that now. VMs, containers, I think Docker is pretty much becoming a de facto standard. I don't know if you agree from what you're seeing there. Containers are pretty much the thing, aren't they, packaging stuff, and I think Docker is becoming a standard. So in terms of building, let's start with the basics. So developing services locally. How many of you use tools like this to develop things locally? Do you use like Boxen or Sprout or Playbook for when you're building a sort of like a local development environment? So I'm guessing, do most of you like configure local development environments manually using Brew and that kind of stuff? General notes there. So these tools are really useful. You can basically configure what local development environments look like. If you're pairing, you want a standard kind of workstation, you can just nuke your workstation, bring it back up, and it's all standardized. It's really key with microservices as well, because there's a heck of a lot of stuff involved typically. Might be multiple languages, multiple data stores, all this kind of thing. And if everyone's got a Snowflake development machine, it's really hard to prove what you develop locally is going to work in production. These are really good. You can also go sort of the Vagrant, Otto route. You can sort of spin up stuff locally, so you're not deploying it on your local machine, but you're deploying it on a VM or container running on your local machine. I've done that a few times. That's quite useful as well. But the key message here, I want you to get away, is that developing locally requires a bit more standardization for microservices than it does for a typical monolith. The naive approach, when you start adding more and more services, is to replicate the environment per service. This soon gets crazy. You've got different languages going on. You might have a Go path, a Ruby, Env, Java, this kind of thing. And then you've got more and more data stores going on. Soon it gets very crazy. So I wouldn't recommend you start off by all means if you're just getting into microservices, use those tools on the previous slide, but be very careful when you start getting more and more services. I'm a big fan of using local profiles and like mocking and stubbing. Spring Boot's really good at this. You can specify your profiles. You can say, I want to mock Rabbit here, for example. I want to run H2 as an in-memory database rather than an actual database. And you can keep things a lot more contained as well. The next level is service virtualization. Really cool tool at Mountebank, YMock. They spin up little servers and you can program them to do certain things. They run next to your process. So you've got your Java app doing stuff and it's talking to this kind of fake service, if you like. You can virtualize. It might be a legacy service, speaking SOAP. It might be something that's expensive to run. Mountebank, YMock, and Mirage are really cool tools for the next level of kind of mocking. You can do the whole production in a box thing, and IFTTT have done a fantastic blog post. I've linked there. I'll put these slides up later on today, by the way, so don't worry about copying stuff, and the links will be online. They've got this production in a box. They literally pull down one VM, one Docker image with everything running in one container, and they work on that locally. There's also companies I know that pull down lots of different containers, and you can build your own little platform locally on your box. And lastly, there's this concept of environment leasing, and I've started doing this a lot more lately, and I took inspiration from Halo, and we're using Amazon in my current project, so you can spin up a QA environment on demand with any services you want. So we've got like 20 services or whatever, and we can say, I want this, it's an e-commerce shop, so you say, I want the basket, I want the payment portal, and you're good to go. There might be a few other dependencies, but you can basically create your own QA environment and test locally against that environment. Quite nice because it gives you sort of the input of going over the wire as well. And you can have your own QA environment, if costs allow, you can help with that, locally to play with, which is kind of cool as well. There's quite a few options there. I've gone into more detail on a blog post. OpenCredo, that's the company I work for. We're trying to blog as much, share as much as we can. We worked on quite a lot of microservice projects. Developing locally is one of the big things we often stumble, or we see our clients stumble with. The Netflix, and they do some amazing work, and they've shared amazing things, but they haven't talked so much about how they do things locally, which I found when you get more and more services, and they are kind of dependent among each other, it's quite a challenge developing locally. You obviously, I'm sure many of you have seen like continuous delivery, Jez Humble's great work, creating a pipeline. If you've got a monolith, you push it along to local development here, push it on a CI server, Jenkins most likely, TeamCity, that kind of stuff. Use Sonar to do build quality, push it into Nexus, Artifactory, that stuff. All makes sense, then you QA it, you might do some load testing and staging, all this good stuff as well. That makes sense in a monolithic world, totally. That's like best practice, recommend that, always get that in with our clients. What happens when you go to a microservice world? Suddenly you've got lots of little mini apps. And there's a bit of a challenge. How do you coordinate all their releases? It's not like Maven dependencies necessarily, where you can say, I version this, I release that. It can be a bit different. So this leads nicely on to the test section of the talk now, because testing is critical for asserting services work together with each other. Slight interlude, I would say always remember the testing pyramid. Have people heard of the testing pyramid? General thing? Yeah, awesome. So units, your code base should be like this in terms of the bigger space at the bottom. There should be more of these tests. So more unit tests than there are acceptance tests, more acceptance tests than there are system and contract tests, this kind of thing. But as they go up, there should be more sort of through the system. So particularly in a microservice system, you want tests that touch critical business functionality. I'll talk about it a bit more later on. But for example, I often recommend testing in an e-commerce site. Can I browse products? And that might touch several different services, but I'm running, say, some BDD framework testing my production website. Can I browse for products? Can I look at categories? Can I add things to my basket? Can I check out? And if at any time this process running those tests fails, we've got a major problem. We need to dive on and fix that straight away. Other metrics, we pick up as well. But I think this kind of thing is really critical. Unit tests, start small, work our way up to sort of actually asserting and testing on business functionality. So I don't know if any of you have seen greater minds have thought of this stuff than I have, but Toby Clemson, part of the ThoughtWorks crew, ThoughtWorks do a lot of great work actually. They are my competitors, but they do a lot of great work. Toby Clemson did this fantastic article about microservice testing. I'm not sure if many of you have seen that one, but I recommend I'm not going to talk too much into it, have a read of this. It's really good in terms of how you sort of break down the different bits of a microservice ecosystem for testing. The multi-pipeline question comes back though. It's still a challenge. A lot of our clients bump into this kind of problem. We've got 5 services now. On 2 of them have got to be a certain version to work with a third one. Or that third one's dependent on the 4th one. It just happens. Be very careful of rubber stamping services. It's kind of the Maven approach. With Maven it's fine. We've got our POM. We say this is dependent on version 1.2, this is dependent on version 5.7. Some microservice frameworks are actually allowing us to do that now, say this version of service depends on this other version. But in general, you want to keep them as loosely coupled as possible. Highly cohesive, loosely coupled. It's just good software development practice, yeah? If you really must version your services, and some gigs I've worked on, we have to, use semantic versioning. I'm sure many of you heard of semantic versioning, the major, minor, patch, and you say if you're doing a major, then people need to be alerted of that. Minor, you should be adding new stuff, not breaking existing functionality, and the patch stuff is just minor kind of bug fixes, security fixes, that kind of stuff. But do be very careful of rubber stamping, saying I've got 5 services and it's got to be these specific versions. Effectively, that is a distributed monolith. Yeah. Now, Simon Brown talks about this a lot. Codingthearchitecture.com, he's got some fantastic work. It really is a pain. You're actually getting a lot of the drawbacks of microservices, the distribution, and you're not getting the benefits of the loose coupling. So be really careful about creating a distributed monolith. I've done it, hands up, right? One bad thing I would say is I did a while back is I created a shared domain model. So So I wanted a domain model for all my services. I packaged it as a Maven artifact, and then I shared it amongst my services. Then the domain model changed, as they always do. Yeah, the client changed their mind, pesky clients. But the thing is, then I had to roll out the change to all my services. I learned the hard way that was not the shared domain model. Best practice in the monolith, not in the new world. It actually increases coupling in the new world, where we have bounded contexts of kind of related functionality, highly cohesive related functionality. Shared staging is an interesting idea for doing sort of assertions. You're pushing stuff through your build pipeline. Before it gets into production, you want to do some critical assertions in staging. Like I mentioned before, can I buy stuff? Can I add it to my basket? All this good stuff. The challenge comes when all different teams are pushing lots of services into one staging. You soon start needing multiple versions of staging. And I chatted to the Guilt guys. If anyone saw the Guilt talk yesterday, it was in here. Fantastic talk by Adrian Treneman. They've actually pretty much given up on doing staging environments now because they've got 250 services. And you don't always need them to assert different things are happening. It's kind of like, how do you coordinate all these 20 teams or whatever working across all these services? It's quite a challenge. So I say, rather than do critical path testing in staging, why not do it in production? Bit controversial. Some of our clients are not happy with that, but it's actually really, for e-commerce, for low value stuff, like not financial stuff. Financial stuff, you have to be really careful with financials, obviously. But some things in the Netflix model, it's actually really useful to push a lot of your assertion testing into production. There's also consumer-based contracts, and a lot of companies, it doesn't get talked about much, but they strive for backwards compatibility all the time. It's really hard to do, but if you can ensure backwards compatibility as you're pushing out services, you never have to worry about breaking things, because everything is always backwards compatible. It's worth thinking about, but the consumer-based contracts is even more interesting. Martin Fowler talks a lot about that. There are some great frameworks out there. Packed JVM is a really cool framework. I use this kind of integration testing when there's a lot of conversation going on between my services. Yeah, it's almost like a protocol at a high level. If I've got services like 2 or 3 that are chatty together, and they're with good reason they're chatty, then you might want to assert on the contracts so that if future developers work on things, they don't accidentally break that contract. The contract is not just a method signature or an API, it might be a series of things in the protocol, and Pact allows you to capture that and run it in JUnit and all this good stuff, maybe in Surefire, that kind of thing. Pact Broker gives you some cool things, like you can see, a bit small here, but you can see what services are dependent on the others. You also get a cool kind of diagram in terms of what talks to what, quite useful. So it's some great stuff. Actually, Matt Stein I think he's from Spring now, has got a great example of how to use all this stuff with the Spring Boot framework. So if you're interested in that kind of stuff, check out his GitHub. Really cool project. My opinion, so I tend to BDD services, and I like Serenity BDD for doing this. And each service should be doing one thing. Yeah, it should be a checkout service, should be a payment service, that kind of thing. There's clear behavior-driven design you can apply to that service. I like contract tests if there's a conversation, and then a failure in a contract test is a trigger for a conversation in your team. It doesn't mean it shouldn't be deployed, but it means it's going to break stuff, and therefore I need to have a chat about, should I push this? I'm breaking this contract. Is it the right thing to do? Modify the tests if it is. Component unit test as normal, Maven Surefire, I'm sure all of us like that good stuff. And I also, as I mentioned, I BDD critical paths throughout the application. So that e-commerce thing, can I browse, can I add to checkout, etc., etc. That's generally how I roll when I approach clients and help them, improve their testing, particularly across microservices. Final word on testing is don't forget the ilities. More and more, as I'm getting into the operations these days, I'm realizing that this stuff is super important. And Docker and things like that give us as developers a lot of power, but it gives us a lot of responsibility. Diane talked about this in the Netflix talk yesterday. Accountability and responsibility. People like, freedom and accountability. People like freedom. I like freedom as a developer. Accountability is a bit scary at times, isn't it? I've got to think about security now. If I'm pushing out, containers with an OS in them, for example, the attack vector suddenly got a lot bigger rather than just a single jar file. That kind of thing. Zap, the OWASP team did great work. It's an open initiative talking about the top 10 vulnerabilities and more from security, from web stuff, from OS stuff. They're an amazing organization. Don't get enough love, I don't think. But they've created this Zap, the Z attack proxy, that allows you to run attacks against your own infrastructure. So don't do it against other people's, obviously, but you can test your applications as you're developing them. And there's this awesome framework called BDD Security that wraps some BDD-like stuff over the Z attack proxy. And you can do some really cool stuff. Given I've got a new session and I browse to this thing, can I attack this by cross-site scripting? All this great stuff. Really cool framework. And I cannot emphasize enough, as developers, we should be paying more attention to this kind of thing. Performance and scalability is super important. I've been burned on this a few times, so now I use the performance plugin in Jenkins, which used to be called the JMeter plugin, to test individual services. So I mentioned like the payment service, for example. That payment service we're writing has to be super available, super performant. So we literally test the happy path constantly as part of our Jenkins tests. And if we notice performance degrading, that's a cue to start fixing something. Previous project I worked on, we didn't have this kind of testing. We were pushing out services, and eventually like the performance dipped to a critical level and the application actually fell over. We were like, what's going on? It took us ages, because it wasn't microservices, it was service-based. It took us ages to figure out where the problem was, because we introduced it gradually over time. So now I always recommend checking for performance, even just basic stuff. It gives you an idea. Is your app doing a lot of GC? Is your app getting stuck, certain places, that kind of thing? Just get real simple stuff, but it's really powerful. Flood.io it's a commercial product, I would say, and there's also a free tier. It's a great tool for load testing. I use this that's my go-to tool at the moment. You can upload JMeter scripts, Gatling scripts, the other bits and bobs, but it's a really cool tool for testing in production, that kind of thing. So on to deployment now. Hopefully that's made sense so far. Anyone got any questions so far? Well, quickly ask. You're good, awesome. So deployment. Key thing is separating deployment and release. You've probably heard this even in the classic monolithic sense, but it definitely makes sense in the microservice world. I find feature flags really useful. Do that quite a bit. Etsy talk about how they do that quite a lot. It's quite difficult at scale and distribution. A few times I've created a feature flag service, and I've had services talk to that service to know whether they should be enabled or what sort of path the application should take. And I found that really tricky to maintain. So what I recommend now is doing feature flags at ingress, as in where ingress makes sense in terms of where something's coming into your app, someone's triggering some kind of functionality, do the flag there. So if you're prototyping a new payment method or something, like maybe you have it in the code path there throughout your services, but you can feature flag an A/B test even at the ingress point, the API or the web UI. I find that much more manageable going forward rather than trying to do these like feature flag services. Definitely think things like incremental rollout, canary, blue-green testing is all great. Push stuff to production, particularly when you've got lots of services. Push it slowly. Watch your metrics, yeah? Particularly if you're doing things like backwards compatibility. Things that break aren't always obvious at first. So push things gradually. Netflix talk a lot about this, probably better than I will, to be fair. So like have a check out what Netflix are doing around that kind of stuff. Etsy, again, are really good around this thing as well. Now the killer, avoid data store migrations if possible. I'm sure many of you use Liquibase or Flyaway, that kind of thing, to modify your schema. Awesome tool, not so good in the microservice world. You definitely probably have a lot of service clustered, so services clustered. So as soon as you push out the latest version of the service, it will modify the database, and all the other services talking to that data store now are going to have a hard time because the schema might have altered. There's also somewhat an anti-pattern. People do say one data store per service, but sometimes you have other services doing read-only. You should always only have one service writing to a data store, I think. But sometimes you want, for performance reasons, other services reading off that data store. Again, using Liquibase, Flyaway, you'll potentially break that service. As soon as you start having to coordinate releases, it's a real pain, I'll be honest. I've done it, it's not so fun. So avoid data store migrations if possible. You can use schemaless tech, like Cassandra, Mongo, if you're really up for a challenge. But I like Cassandra a lot. If you're on Amazon, there's things like DynamoDB, all that good stuff. I still really like MySQL and Postgres. I have a lot of love for SQL, genuinely, yeah. But you just have to think about some of the modifications you're making. And at some point, perhaps a year in, you can go back and scrape out some of the old modifications you're making. And then you can take the hit perhaps once a year to do some breaking change. But fundamentally, if you can, avoid data store migrations. Centralizing configuration is another key thing. I'm a big fan of console. HashiCorp console, really good, but you can use Zookeeper, etcd. I've got a few mentions on the slide next. Take your pick. But I really like the idea, it helps developing locally, to have configuration files associated with your jar, for example, or WAR. So I'm a big fan of Spring Boot, as I keep mentioning. Other frameworks do exist, Java EE. But a Spring Boot, you can often have different configuration files for different profiles. This is my config for local, this is for QA, this is for prod. You can use things like console and console template. Console template will hook into console, and all console is a distributed key value store. So you might have the feature flag thing there, you might have some form of configuration, something, turn the knobs of your application basically for functionality. Console template looks at console constantly and updates the local copy, be it in Docker, VM or whatever, of your config file. Yeah, and I think that's really nice in terms of like Netflix use Eureka and a few other things, and they're pushing stuff into memory. Whereas these things, I found them more useful for sort of maintaining state and other things, and also just easier for testing. We have like a local profile for testing, local config for testing, QA config, that kind of thing. But centralizing your configuration is essential. Don't try and push it all out using, Puppet or Chef or whatever. I find in microservices that gets really cumbersome. Big problem with pushing out stuff via certain tools like that as well is you can't choose when some things pick up the new config changes. Puppet, you can configure it multiple ways, but it's very classic to have people services poll Puppet for changes. And if something polls, just at the right time, gets the change, and the other things say you have to wait 30 seconds before they pick it up, it can actually break an application if you've got incompatible config. So I'm a big fan of this kind of thing, centralizing configuration using an appropriate tool like Console, etcd, Netflix, that kind of stuff. I've just put names there if you want to go in and have a read about them. I like HashiCorp stuff, I'm not going to lie, I like HashiCorp stuff. It's really well engineered, really well documented, so I use a lot of their stuff, but other things do exist. Oh yeah, and one thing, watch out for application rollback as well. I've been burned on this one a few times. You're pushing out new versions of application, you change the config or the config's different or whatever. When you roll back, don't forget to roll back the centralized config. Otherwise, you like BlackRock, I think it's BlackRock was one of the banks is famous for causing a lot of problems with this, whereas they reused the feature flag. But then something went wrong, they rolled the application back but left the feature flag in the new state, and that feature flag was completely different in the old app than it was in the new app. So do be honestly, and I've been burnt by this, be really careful. Think about rollback. The more things you push out and distribute, you've got to sync them up. But I think this is a hit I'm willing to take for centralizing the actual configuration. Operations. So I hinted at this in the previous talk I did actually. I would recommend definitely getting more into ops if you can, learning about ops. I think that the days of just being a developer, just being a Java developer, just being a JavaScript developer are probably coming to an end. I think you need to be full stack to some degree. That's just my opinion, obviously, very subjective there. But think about the ops stuff. A couple of things that have really got me as I've moved more into the opsy side in addition to Java is standardizing on the OS. So for example, it's very easy to fire up Ubuntu locally on a VM because we all like Ubuntu, yeah. But then if you're deploying to Amazon Linux behaves in subtly different ways to Ubuntu. So it's like the same thing. If you're working on Java, Java 8, you wouldn't work on Java 7 locally, would you? Do you know what I mean? Whatever you're going to push to in terms of production, you should always standardize the environment as much as possible. The same JDK, be it OpenJDK, be it Oracle, the same version, the same security patch, everything. And the same goes for the OS. Minimize the deviation of things, and otherwise you'll have weird issues. I've had some really bizarre networking issues where I was doing some tricks on one distro that didn't work on another. My fault, obviously, but I made it harder for myself by having different distros in the mix. Do think about being able to just raise your infrastructure to the ground and build it back up. It's really powerful, and HashiCorp Terraform are awesome at this. Terraform is kind of like the next level up from, say, Puppet, Ansible, Chef, SaltStack. You define your data structure infrastructure. So you can set things like you can use like Amazon EC2 instances, you use DynDNS for the DNS, you use DigitalOcean for other things. It allows you to it's like CloudFormation, maybe you're familiar with CloudFormation at Amazon, but it's very powerful, and it allows you to basically, trash your infrastructure, bring it back up, and move clouds in theory. It's a little bit nuanced in terms of moving clouds, but it's a very powerful tool and well worth learning. The CAP stuff I mentioned, we call it CAPS, it's just like Chef, Ansible, Puppet, SaltStack. It's basically automated sysadmin stuff. I highly recommend getting into that. Ansible is my current favourite, I really like Ansible stuff. And the reason I'm kind of mentioning these things, I think it's really interesting for us as developers to learn about this stuff. But it goes both ways, the whole DevOps thing. I go into a lot of companies where operators now are starting to program. Yeah, they're used to doing Ruby and shell scripts, Python, this kind of stuff. But more and more, this infrastructure involves actual programming, and they're not so familiar with things like Solid. I'm presuming most of you are familiar with the Solid principles, Uncle Bob's Solid principles. So basically it's cohesion and coupling, thinking about that, single responsibility, open closed, all that good stuff. So I'd like to say, a slight deviation from the talk, but I'd like to say, take this kind of thing as an opportunity to work closer with your ops team. Share your knowledge. Yeah, you've thought a lot about cohesion, coupling, architecture. They may not have yet. They may do, but they may not have. And things like Git flow. How you work with a code base. Do you commit to integration? Do you commit to a master branch? How do you work with branches basically in Git? It's often unfamiliar with some ops teams. And I one project I was working on, we were developing apps and infrastructure at the same time, and it was a nightmare because we had master branches of both and integration branches, and it was just really fiddly because the ops team in that particular scenario didn't know about they shouldn't be committing to master broken code. I know we all might like scoff and say that's an obvious thing, but they just didn't know it, or they weren't testing, that kind of thing. So I think it's an opportunity to work closer together as dev and ops, the true DevOps thing, yeah. Culture, tooling, all this good stuff. Service discovery now, on to the next bit. Two options really when you're looking for services. Say you've got some service, service A here, you want to talk to service C, there's a couple of service Cs, service B in the bottom there. You've got a couple of options really, and it's external, where you have like say a load balancer in front of the services, or it's internal. You sort of bake in the load balancing to the actual services. Yeah, I think this is often easier to get started with, and if you're using things like Kubernetes and Amazon, this is kind of the default way of doing it. It's nice and easy to auto scale as well. If traffic is coming in a lot here, we can trigger that like load balancer to say, oh, spin up more service Cs, that kind of thing. It's very easy to get started, and you when you deploy a new version of service, you just have to tell the load balancer. And loads of services can be all coming into that load balancer. It's nice and easy. But there's a lot more cool tricks you can do with client-side load balancing. I know Netflix are very famous. They use something called Ribbon to do like client-side load balancing. You can do kind of A/B testing type stuff. You can do like clever stuff around like they use like Hystrix to load shed if there's like things getting overloaded. All this good stuff. But do have a think about what's appropriate for your use case. Is it easier to update just say like an HA proxy in Nginx that points to other services? Do you want to scale really easily? Just if there's load increasing on those external things, add more Docker containers, add more Amazon instances, that kind of thing. If you want more power, and particularly with like some of the Docker stuff I've been working on lately, we've been using like Netflix Ribbon. Baker Street is a new thing coming out. It's real hot off the press, and Google for that one. Some of the guys actually reached out to me from the microservice mailing list and said, hey, check this out, it's really cool. So that's quite nice. And there's some really funky stuff you can do with it. It gives you a bit more power at the cost of a bit more complication. Really quite cool. Kubernetes, I mentioned, are good. They have this concept of services baked into like their framework. Cloud Foundry, good to go. They have this notion that it's a PaaS. They're a bit more opinionated about what they do, but it's easier for us as developers to kind of leverage what they're doing straight away. Final thing, observing. Now this, if you saw the previous Docker talk, I talked about this a lot. Observation of stuff in production and even in QA and testing is really important. In production, arguably the people are the most important thing, yeah. Now, there's a great talk actually about Mikey Dickerson. Mikey Dickerson came in, I'm sure many of you knew about the healthcare.gov scenario that went on over here in 2013. I followed that quite closely, it was quite interesting. Whole bunch of stuff, I won't go into details of it, but fundamentally Mikey Dickerson and his team came in and rectified a lot of the problems with healthcare.gov, got it back up and running within a month or two. The biggest problem they had was the lack of monitoring. They were literally looking at CNN to see if the website was up. That is crazy. That was their information radiator. CNN is like, oh, site's down again, better reboot, that kind of thing. Which he was like, Mikey Dickerson comes from Google and all these other companies. That's crazy, yeah, but that's the kind of level you do see in some organizations. But once you've got past that basic monitoring, yeah, I'll talk about it a bit more in a minute, health checks, all this good stuff, then it's all about how do you and your team handle these things. Incident response, post-mortems, fundamentally culturally driven. I worked in too many organizations where people are quick to point blame and not quick to accept it. I've worked in some fantastic organizations on the flip side of that, and I've been fortunate enough to have been invited into Google and other places where I've seen how they work. And as much as we might scoff at Google sometimes, they are truly amazing in terms of culture. They have blameless post-mortems, this kind of thing. And when you get it working right, it is amazing, and it just harmonizes the team. And you basically get rid of all that politics rubbish and just get stuff fixed, yeah? Because we're all going to make mistakes, aren't we, to be honest, But you need to think about if something goes wrong, there's things, people run game days, like Chaos Monkey type stuff, pull the stuff out in your data center, see what happens. Does the right person get paged? Do they take the right action? That kind of thing. They also call it dirt sessions, disaster and recovery training, that kind of thing. It's a lot about the people. Basic monitoring, fundamental, but then it's all about the people. It's that DevOps thing, yeah? Culture. Start with the basics. Health check. I'm a big fan of Coda Health, Drop Wizard Metrics, Spring Boot comes out of the box, Spring Boot Actuator, really kind of cool. Basic 200 HTTP, I'm good, I'm up, I'm available for taking traffic, that kind of thing. Typically, I'm using Amazon quite a lot lately, I'm putting the Spring Boot health check on the load balancer check. So the load balancer only sends traffic when the service is up and good to go. KPIs are really important for apps and business. And this, I think, once you've got your health checks on, think about what matters to the business first, is my advice. Then think about the technical stuff. So the business cares about how many checkouts are going on, that kind of stuff, yeah? What's the value of checkouts? Why are my top items not being seen by more people on searches? Think about assertions and invariants, stuff that if something's going wrong, it might be subtle in terms of a technical difficulty, but you want to know what's going to actually impact your users and your customers. Some people are calling this symptom-driven monitoring, which I really like. Basically, think about the business impact. If someone cannot do something in your app, alert on that, and then dive down into further stuff in terms of like throughput, queue length, is the database up? Too many times I've gone into organizations, database has crashed, and alarms going off, everyone knows the database has crashed, they've got no idea what impact that's having on the users. Sometimes the database crashing, no big deal in microservice architecture. Reroute around it, or there's some backups, there's a cache involved, fine. But the amount of panic I've seen when people go, oh my god, database is down. Like, what's that mean? Don't know, let's fix it. It's like, have a think, is that actually impacting you? There might be some other things going on as well. Think about symptom, think about business issues, as opposed to tech issues first. Logging is really critical, and I mentioned this in my previous talk, so log like an operator is my advice, Think like an operator, think like a sysadmin. Too many times I see log statements like, if this happens, call Bob. And like, Bob's a programmer, and Bob's nowhere to be found. Bob's left the company 3 months ago, that kind of thing. Do log like an operator, give meaningful log messages that will help your operations team when they're looking, when he or she is looking at the logs and going like, what's going on here? Oh, this happened, or this didn't happen. Make it easy for them to figure out what's going on. Then they can, you'll probably be on call as well, perhaps as a developer, but a couple of great links here for how to log properly. Too many times I see people like either going no logging or log crazy. There's a nice middle ground there where you're logging to help you and your ops team when things are going wrong. And Elasticsearch, the Elk stack, Elasticsearch, Logstash, Kibana, really cool. Loving that. So Kibana is this kind of like funky GUI here. It's like really nice. I use that. I use Kibana and Grafana a lot on my gigs, and they're really nice for like information radiators and stuff. But fundamentally, they're really cool tools. Do think about mounting, like if you're using container stuff, like containers are quite ephemeral, so are VMs arguably as well. Do think about that. All too often I've seen projects where we've lost logs because the application's died and trashed a container or trashed a VM so spectacularly we can't pull the logs out. So ship the logs off to Logstash or somewhere else, get it off the box as soon as you can, or mount a directory into the container and have, like if you're using Docker, store your log files on the host as opposed to in the container. That makes sense, You want to be able to do post-mortems. Basically, if you don't do that, it's the perfect crime, Something goes wrong, logs get blown away, no one knows what's happened. Really key to get the logs off the instance off the box. Command I mentioned is awesome. Zipkin, I'm really a big fan of Zipkin. I've talked about how to do this kind of stuff actually on my GitHub. Zipkin is for distributed tracing, and this is a big shift in the microservice ecosystem in my mind. No longer are you putting something into a monolith and something dropping out at the end or going to a database or whatever. You might have multiple services involved, So something comes in, it might even get fanned out to multiple services, it goes down and calls another service, that service calls another service, it hits a data store, it hits a cache, all this stuff. And it's really tricky without a way of correlating a user's action to those things, figuring out what went wrong, So what I've talked about putting a correlation ID, something like a user's request comes straight into your application, you give it an ID. Oh, that's request 1. And you pass that correlation ID all the way through the stack, right to your data stores, all the way through. You can trace it not only in logging, so you can use Kibana and stuff to search for that ID. You can see the journey that request has taken, but you can also use tools like Zipkin. It's a bit like the Firefox debugging thing. Everyone's used that Firefox, Firebug, whatever it's called. You can actually see here, this service handed off to this service, then this service split their request to other services, and you can see which service is taking the longest, all this good stuff. It's a really cool tool, Zipkin. It came out of Twitter. Now it's completely open sourced. Adrian Cole's guy working on it actually. I think he's around the conference actually. They're doing some amazing work. They've got a Docker Zipkin, which is good to go, because the Zipkin, it involves Cassandra, a couple other services as well. They've got a Docker container now which encapsulates all that together, so you can have a very quick play with Zipkin, and it's really cool. It's kind of like AppDynamics. Everyone uses AppDynamics, but it's free, which is good. AppDynamics is quite expensive. Monitoring, think about push and pull. It's very tempting. I often joke and I say log everything, monitor everything. But do have a think about how much you want to be sending over the wire. Often it's better to kind of expose endpoints with all your metrics you could ever be interested in and maybe refresh them every few seconds, but only pull down what you need to sort of do critical tests. Telegraph is a really cool tool for doing that. Telegraph plugs up to InfluxDB. You can select what things you pull down from metrics. If stuff goes wrong, you can suddenly start pulling more things down, But fundamentally, if you're pushing a lot of data over the wire, it's very easy to basically take up all your bandwidth for doing that kind of thing. There's so many tools in this space: Influx, Prometheus, Graphite, OpenTSDB. Like, I find it hard keeping up with all this stuff. So I put some links there. There's a cool blog post where someone's talked about where they think these tools are best placed, because they're quite. Prometheus, someone actually asked in my last session, Prometheus is quite an opinionated way of logging, whereas Influx is kind of like a very, it's just a data store, basically, time series data store, same as OpenTSDB. Information radiators are fundamental. Like, you've got the data, but you must make sense of what's coming in. Like, that's the only value you're going to get, yeah? It doesn't matter how many metrics you got. Can your business, can your ops team, can you understand what's going on, yeah? And it's, the thing I've really struggled with is this aggregate versus individual, yeah? So sometimes you want the aggregate view. What's the average of, my checkout time here? Sometimes you want the individual view. Like, 1 out of 10 checkouts is taking like 50% longer or something, yeah? This swapping between the aggregate and the individual is really key. So like, when you build your metrics, bear that in mind. And I think that I've got really put into the whole aggregation thing, and I've actually been burned by that quite a bit. The individual was often quite useful. The reason I think I got put into this aggregation thing is the notion of cattle, not pets. Have you heard of that? So people are saying in microservice, don't treat your containers, your infrastructure as a pet. Like in the old days, you had like bare metal, you provisioned it, you named it, probably some geeky Star Trek name or whatever. That's what I certainly did, and that kind of thing. And you looked after that instance, that application or whatever. Now you move more towards this cattle mindset. That if something's sick or broken, you just nuke it and start again. But the problem is, like, sometimes reality is you have got a pet, or it's a prize bull. It's still cattle, but it's a prize bull, yeah? So think about different levels of aggregation. Sometimes you want to know, the big picture. Sometimes you want to know the individual pictures. And a classic example of this, actually, Amazon recently had a massive issue on the East region. Their region disappeared. They brought their stuff back up. They were seeing an error rate of like 0.5%. They were thinking, we've got it fixed, an error rate of 0.5%. We can live with that. The problem is that 0.5% affected 1% of their customers. So basically 1% of their customers were getting completely trashed. They assumed up front it was like 0.5% distributed across everything, which wouldn't have been too bad, yeah? So Amazon, they've done a great post-mortem. If you search for the recent Amazon region outage, like they're like Google. They're fantastic in terms of what they, no finger pointing. It's like, what went wrong? How do we fix it? And you can see like their engineers, they're just like us. They're trying to fix stuff. They're just pulling things out, putting it back in or whatever. But they were talking about like making assumptions in terms of aggregation versus individual can be damaging. Grafana, really cool tool, much like Kibana. We use that a lot. It's open source, really cool. Builds some really cool information dashboards, that kind of thing as well. If you've got problems, it's a great article by Rob. I'm going to not do the name right ever. Philosophy on Learning. It's a Google Doc. So when you go there, it's a Google Doc. I think he's from Google, or he might have moved on now. But he's basically created a Google Doc about how to do good alerting. And a lot of my stuff, like I was doing before, I picked up from colleagues and friends over the years. It's just perfectly captured in that document. So I'm not going to talk about it too much here. It's just like, if you want to know how to alert stuff, like this, like Rob's stuff is awesome, basically. So is Brendan Gregg. I don't know if any of you saw the Netflix Flame Graph talk here. That was Brendan. Brendan's a really cool guy. I've not actually met him personally yet, but like he's got some amazing stuff out there. And he talks about the use method, which I found really useful when I've got problems. And use is check utilization, saturation, and errors. That kind of thing I mentioned earlier on. Like utilization, is something kind of like saturated or whatever. How is it being utilized? What's the error rate? Again, I won't go into it too much, but that's a great link to, he's published papers on this stuff, nice blog posts. He's really done a lot of thinking about this stuff, so I respect his thinking on that. And I've learned a lot from this book as well, DevOps Troubleshooting. It's a smallish book by Carl Rankin, but it talks about a lot of ops type debug tools and all this good stuff that are good for me as a developer. Yeah, like for me it was like probably a couple of days worth of read on the train home, and it was really good in terms of figuring out like how I should think a bit more like an operator when things are going wrong. Really good. So, the summary. We have looked at microservice platforms. Like I said, pick your poison in terms of Cloud Foundry, Deus, Amazon ECS, build your own, whatever you like. Local development is the first thing I often, once we've got a few services in the mix, we're breaking down a monolith, say we've got a few proof of concepts in the mix, all going well, we often start to run into problems around the 3 service mark. Particularly if, like one project I was working on, we brought in some Java in the stack. It was primarily Ruby, and the ops team weren't really used to how to work with Java, for example. So as soon as we got multiple services in the mix, it suddenly got a bit more complex. Yeah. So think about that. Think about techniques I mentioned: service virtualization, the rent platform type thing, all good stuff. Think about your build pipelines. Fundamentally, how things work together now is a real challenge, yeah? So whether you make them backward compatible, whether you do some kind of versioning, some kind of API versioning, all these things, do have a think about it. It's definitely caught me and my team a few times. And the testing goes hand in hand there. Like, I really like the consumer-based contracts, that they are a bit of work, but for services involving communication or conversation protocols, I find contracts really useful for verifying changes we're making are not breaking old stuff. It's very easy to assert, does the API look like this? It's hard to assert, does the API behave like this? That makes sense, yeah? So pact is really cool there. Do consider the infrastructure. Both from as a developer, I think we need to be more aware of operational stuff now. We need to be more, and the more stuff we learn, the better it is all around. We understand things. We can communicate with our ops team better, and probably a bigger paycheck we get as well. And the more things we learn, it's all good stuff. But I think also we can help the ops team as developers. Is really key. We've over the years crafted good architectural skills, coupling, cohesion. As developers, we've really thought about this stuff. And some of the ops teams I encounter, not generalizing, but some of the ops teams I encounter aren't so familiar with this stuff. So the whole DevOps thing, teaching your ops team what you know, sharing what you know around good development practices, including code and branching and Git and all that good stuff as well. Do plan for inevitable issues. Like I say, the logging, the monitoring, all that stuff is essential. And I mentioned in my previous talk, I say get as much as you can up front and then dial it back. Because there's always a cost to things, in terms of particularly if you're sending data over the wire, all this stuff, there's always a cost. But up front, put as much as you can in, then dial it back as you get more confident, So I often say, the talk I mentioned before with Docker, I was saying, with Docker often, first month of production deployment, I'll put a JDK in my Docker container. So I've got access to JStat, JMap, JPS, all these things. If I really need to, I can go onto the container and start debugging stuff in the container. But by having a JDK in a container, the attack vector is much larger. So as soon as I can, I remove the JDK from the container. That's just one example. What I'm trying to say is go crazy at the front, then dial it back. As you know, you want to always minimize things in terms of performance and in terms of attack vector as well. It's really key. Final comment is with this microservice platform, I tried to keep it quite general in terms of things I've stumbled across as I've been developing microservice platforms for the last 3 years, whatever it is. And one key thing is try not to create your own platform if you can help it. A lot of us who were in it from 3 years ago using Mesos and all this stuff, Kubernetes for its GA, we kind of had to do our own stuff, but I think the industry is almost mature enough now for us not to make that choice. Or we make that choice, but it's an informed choice, So don't just start putting, my recommendation I should say, is don't just start putting things together just because it's fun. It's very tempting, Docker is super cool, It's very tempting to start building your own platform, but you're going to create a lot of potential hazards for your ops team if you're not careful. That's my general experience. So do think about this thing. Colin, one of my colleagues from in the UK, Colin's very much into Cloud Foundry. He's a CEO of Cloud Credo over there. And he joked about this. He goes, started writing my own scheduler, blah, blah, blah. It looks like you're trying to build a platform. And I see this quite a bit, teams we go into, because a lot of the DevOps stuff is being pushed up by us as developers, but we don't communicate, my generalization again, we don't communicate enough with the ops teams. They have got, particularly in big organizations, a lot falls on the ops team's shoulders, Things like security, compliance, all this good stuff. So I think some of the platforms as a services we're seeing being created now have got this stuff baked in, and they're a bit more aware of these things. So do think twice if you're going to start creating your own platform, On that note, thank you very much. I'm happy to take questions, so feel free to ping me on email. I'll get back. I'm traveling back to the UK actually the weekend, so I won't be too busy on the email. Twitter, always happy to get you on Twitter. Move Services Weekly is the Microservice Weekly newsletter. Please do sign up. Please do share stuff as well. And you come and chat to me now or ask questions. I'm totally cool. I've literally got to shoot off at 12:30. I'm doing one more session over in the Hilton, so I'm around for 10 minutes, I guess. Thanks a lot.
So what's your recommendation of the database?
There's no one size fits all, I would say. I say SQL, unless there's a reason to not use SQL. So I like Postgres a lot. MySQL is really cool as well. Amazon, I use the RDS, their thing. But my go-to data store that's no SQL is Cassandra. Cassandra is operationally expensive to run to some degree, but it scales much better than Mongo, for example. So on Amazon, I really like DynamoDB. Redis is really cool.
What about Couchbase?
Couchbase is really cool. Yeah, I know Arun actually. Arun's just jumped ship to Couchbase. Couchbase is very cool. They're actually doing some really good stuff again, I'm not sure if their product open source. I don't know, often some companies charge certain things, don't they? So you have to bear that in mind as well. But definitely think about your use case. Do you want key value? Do you want table? Do you want graph? Neo4j is really cool and graph stuff. Definitely have a think about that.
All right.
Cool.
I want to ask about the testing in production versus testing in UAT.
Yes.
You're saying try to move it and test in production, but I was thinking if then all the other services also testing in production, then
Yeah, it gets a bit crazy, doesn't it?
Yeah.
Yeah, I hear you. Like it's more recommendation, as in, and it's
Yeah.
something to perhaps aspire to. And most of the organisations I've gone into, like definitely have QA and then have staging. But like the people I'm speaking to are quite advanced, like Gilt, Amazon, all these people. Like they got to the point where they had just too many services, where they had to change their mindset. They had to go like, this is just not working. Like you're creating a staging environment, and then she's creating a staging environment 5 minutes later, which is completely different. So the only place to assert on stuff is in production. But I get what you mean. The same with like Netflix. Like they talk about failure a lot, but they're very conscious like they're just a video service. They're not a financial service. Yeah, if they're a financial service, like failure is a whole different thing. So it's always treat your use case as it dictates. Does that make sense? So I'm definitely not saying you're wrong by testing in QA. I think it's a great approach. If you can move that mindset of testing in production, it's kind of cool as well.
Yeah, but I mean, right now we're testing in QA, but then we end up having to create a lot of staging environment.
Yeah. Yes.
All
There you go.
10, 15 microservices.
Yeah.
Trying to roll out at the same time.
And it just gets hard to coordinate it all, doesn't it? Yeah. Here. So have a check at what like Halo and Gilt are doing. If you ever Google, they're both very good. They've shared a lot of stuff online. So like they are really good in terms of like a reference for what you might be struggling with.
Thanks.
Cool. How's it go?
We're starting on our journey of microservices. So here's the scenario, right? You can have one database for every service.
Yep.
But the problem is, whatever you insert here is to be used by this service later.
Ah.
It's not supposed to be immediate. It could be
Eventually consistency.
right?
Yep.
So we're starting to go with this model, but I don't like it because I have a single point of failure here. So have you seen this? Is there any other way other than triggering and putting anything else there?
Yeah, so a couple of things, like feel free to drop me an email and I can give you a bit of a longer answer because I've got to shoot off in a minute, but something to think about.
This is it, right?
Bingo. Yeah, something to think about is sometimes we have like read-only access to the data store, so keep them segregated but allow read-only access sometimes. Another really cool pattern, but it is advanced, is called CQRS.
Complex event processing,
yeah, and event sourcing.
Yeah,
like I recommend in this kind of thing. Like I've seen that kind of thing, and we use event sourcing.
I'm looking at that as well.
Yeah.
But it
is complex.
It is.
Like that, I mean, I'm loving it, but it is complex. Yeah.
The other thing is behind this is the batch that runs at night, which
Yes.
needs all that stuff.
Yes. So there's a couple of great books. I've got other slides online where I've covered exactly that problem. I've got a presentation called The 7 Deadly Sins of Microservices, and that talks about that. And there's two patterns. One is in Raz Al Gautam's book, and one is in Sam Newman's book. And they talk about like exactly that scenario, because literally everyone I work with has that problem.
I'm going to send you an email. So.
No worries. Cool.
Sorry.
Thanks a lot.
Thank you.
Cool.
Thanks for
How's
the
it
great presentation.
Thank you.
One question is, how are you managing like services? Let's say if you have 100 microservices, how are the versions managed? I mean, because you have a continuous, like.
If you've got like 100, like that's a different issue. Like 10, you can kind of manage even like with semantic versioning and stuff.
Sure.
100, I think the mindset is you have to switch to making things either backward compatible, so you're constantly pushing stuff out and it doesn't change, you feature flag it or whatever, or you use contracts.
Yeah.
I think at that scale is the only thing that works.
Okay.
Because if you like,
guys use some kind of tools, like we've used business spaces, but from
I don't know,
IBM.
actually. Interesting. No,
Yeah.
I tend to work more the open source thing. That's not to say that the IBM stuff's bad. I love the IBM stuff, but just my clients are more interested in open source stuff. So with the one I mentioned, we use Pact Broker. That's quite cool for doing that kind of thing. That's pretty much the only tooling I use actually at the moment. Yeah, on that
Okay,
space.
but you're right about using API keys or somehow.
Yeah, it's better. Like if you start making two things much like a distributed monolith, there's a whole heap of pain. We had to start deploying things like 10 services together, and it was like quick. Like everyone was panicking and making sure everything's synced up, and it was just a nightmare. So yeah, I'd recommend at your scale to move away from that notion of versioning if possible.
Okay.
Cool.
Yeah, thank you.
Nice one.
It caught my ear, the expression distributed monolith.
Yes.
Can you elaborate a little bit more on that?
So I didn't make it up. There's a guy called Simon Brown over in the UK, where it's actually, in an island near the UK. And he's got some really great blog posts. So if you go to codingthearchitecture.com, and have a read of his stuff. So the key thing is, if you've got all these separate services, but you have to deploy them together, it's effectively a monolith. Does that make sense? So, and he coined the phrase, it's a distributed monolith, because like fundamentally, like they're often distributed services, even if you plug them together, but it's still acting as a monolithic unit of deployment. And he's got some great blog posts explaining like why it happens, how to overcome it, and all these other things. So he's got more info on that than I have.
Okay. And do you think that microservices exist without REST, or REST is only the only option?
I think REST is a nice, easy entry point. But I've used I've used Thrift, Thrift, protobufs, gRPC now it's called. I think REST is an easy starting point. If you need contracts, like the Thrift is an IDL, so you can define contracts, and it's also binary, so it gives you higher performance as well, then by all means move to that. But I think they're generally more complex, and you have to share more things. Like REST is very loosely typed,
Yes,
yeah?
exactly.
I love the loose typing. I can just reach in and grab that one bit. Postal's law is another thing, like, you be conservative about what you send out and that kind of thing. So whereas Thrift, it's a lot more, you're heading down the RPC, remote procedure calling route, and that's great, but that comes with a series of drawbacks as well.
Yeah.
So
the alternative you think is Thrift or?
My Thrift or gRPC. I haven't done enough with gRPC, and the Google guys we work with Google quite a bit, and like they're saying it's awesome, and I can't trust them, but also it's their product.
Yeah,
so
it's Google.
Yeah, exactly.
You should trust them.
But like, I've used Thrift more. So I've all my projects I've used like probably, I don't know. In fairness, I've used like REST 90% of the times, Thrift like 10, and then protobufs, which is before gRPC, a few times kind of thing.
Is it binary or?
Binary, yeah, binary IDL.
But all the RPC ones are actually deeply coupled. So you
Bingo.
have to know the method names with REST. All you need to know.
It's
put,
just
delete,
the path.
post,
Yeah.
get.
Spot on.
Yeah. YAML's a nicer version than JSON.
Great talk.
Thank you.
Yeah, it was
Little
great
bit.
talk.
Thank you.
Overwhelmed though. Too much content.
Yeah, that's one of my problems. I do put too much content in the slides.
Yeah. So just because we started to do lots of monitoring, graphing, alerting, all of that. But the common problem with us is what do you do with the alerts?
Yes.
And 90% of the chance, for instance, we know the only solution is to reboot that box.
Yeah.
And we get this angry alert, and then we go reboot the box. Is there a known solution or known tool for me to script a solution based on symptoms?
Yeah, so in the past, I've used Nagios, however you pronounce it, a bit old school.
Yeah.
I'm using Datadog in my current project. Datadog is a SaaS monitoring tool which you can put hooks into.
Yeah.
We've also used, what have I used? There definitely are tools out there. Like I use Amazon quite a lot. I like Amazon stuff. And Amazon, like you can often set so put things behind a load balancer, and if they fail, if they're unhealthy, they just get recycled.
Yeah.
Be it Docker containers, be it VMs or whatever.
Yeah.
So I like doing that kind of thing. But you're right, like an alert should always be for actionable things. It should never be like, hey, this has gone wrong, or you need to reboot stuff. It should like in an ideal world, it should never be that. If something can be recovered, it should be.
Yeah.
But it's hard, isn't it? I get you.
Now I had to gathering all the metrics, and once reaching a threshold, push it to console again. Console triggers a script, does the stuff. It's very scattered. I'm just wondering, is there a nice tool to actually help us?
No, it's definitely something I've come across in a lot of my projects, and ultimately we've if the company's happy with Nagios, we use Nagios to do like call a shell script. Right. If you go into the cloud, like Google, Amazon, all the clouds allow you to do that kind of thing. You set health checks. As soon as it goes unhealthy, boom, gone. Yeah. But then some legacy applications I've worked on, we can't simply recycle it. You have to check stuff and then recycle it. Yes. So like a lot of what I'm talking about is like the idealized version. The reality is often different. Right. Like I should probably make that clearer, but what I tried to do here was stuff to aspire to, but you said, like, I experience exactly what you've said every day.
Right.
It's hard, isn't it?
Thank you very much.
You're welcome. No worries. How's it going?
It was a great talk.
Thanks a lot.
So I just wanted to check if you guys, you have ever commented
or whatever you want to call them. And I hate like using that term, but like they just drill. They have certain people with certain talents, and they drilled into the way, and they're very good at what they do. But it doesn't always replicate to other people's use cases, and we can't all get PhD grad. We don't all want PhD grads. Like it's just like people forget, I think, and myself included, that Netflix are very specific. Like
schedule Wednesday. Maybe the next one. What are the things you must do?
So actually, some of the guys pull back to plug in. It's a little weird. They'll plug in, or they're pulling back because they don't like sitting right next to somebody.
Right.
It's a little odd.
No, these are a little together.
Yeah, I don't think these. I think they're used to being with people. That's my opinion.
Working on it too.
Needs to come when you're sleeping.
My name's Joe Cashmore.
All right, that's the man.
How are you doing today?
Good. I'm going to help you out. They were asking about you, so I'm sure they were like, plenty of time.
Yeah, I just had to find a restaurant and a couple of.
No kidding, and just crossing through the hallways is a challenge.
Okay. What kind of connect do we have?
I have HDMI.
That
and
works.
I have VGA. Okay, well, good. HDMI works. That's the best looking.
That works.
All digital all the time. And then you don't need the internet line up here, right? We don't need the Cat 6 up here, no?
Nope.
Okay, good. We'll put that down.
No,
we don't need your VGA cable. We just need.
Okay.
It's going to go this way. Get rid of that one. This is the important one right here. You don't even need a mouse, right?
I don't need a mouse.
That's a good thing.
It goes right in here.
We're going that way. Okay, and you will be on camera.
Okay.
Here comes the cameraman, Cliff.
Hey.
Derek
nice to meet you,
Ashmore.
Cliff.
And I'm going to take this.
We're gonna make you look real good.
Thank you very much.
And this, live.
All right.
So with that being said, that would be great if you could time your movement to the podium.
Not a problem. I can do that.
When you make references, could you reference to this when you do?
Will do.
And if you have 30 seconds, I'd like to show you something.
Okay. Thank you.
Good to go?
All right. Let me plug in here.
This mic should do you just fine.
Okay.
Get that pointed at you. It'll pick you up as good as 4 or 5 feet behind the podium. So don't
Gotcha.
worry about your
Gotcha.
distance.
I just.
You got a good 6 minutes left, 5 minutes left, so it's
All right. Do we want to?
yeah, you want to switch it up? We'll see what it looks like. There you go. Well, you're on extended right now, so I don't know if you mirrored it, but you got your extended desktop. Which
Okay.
is fine. You can,
Well, actually, hang on.
right.
There's a way to do this. I've run into that before.
yeah, I always like the function projection button. That's just a hot switch. One thing,
Yeah, I know. There's a way to do it. I've done it before.
You need to turn mirroring on of some sort.
Yeah, there is.
Under display settings, are you in that area? Let's see.
Always show in a bookmark.
Trouble keyboard display settings.
Display
There,
settings.
There,
There we go.
there you go.
And actually, I want to start mirroring.
Yeah, that's it. So now we should have you. And there
You
are.
do.
There
All
you
right.
go.
Cool. Let me get to what people care about. And
There you go.
I
Great.
hope you don't mind I brought a little hydration.
Okay. Not at all. Not at all. Do what you can. All right.
All right. Thank you.
You're welcome.
We're good? All right. Can everybody hear me? All right. Wonderful. My name is Derek Ashmore, and we're discussing microservices, specifically microservices written in Java. This won't work for the people who are viewing the stream, but by show of hands, who has seen at least one presentation or read at least one article about microservices? Oh, most of the group. Okay. I did notice a few that hadn't, so for them I'm going to include a short definition section to level set, but it'll be short. Essentially, let's move on to who I am. I'm a professional geek. I started working as a geek professionally in '87, which puts me at old but not quite ancient. I've been involved in Java technologies since 1999, and I've moved around a lot. I do, in addition to being a developer and architect, I've taken tours of duty as a project manager, as a Oracle database administrator, as a DB2 database administrator, as a Unix sysadmin. Translation is I get bored easily and I move around a lot. I'm also a little bit weird as I spend my off hours writing, and basically I've got the Architect's Handbook out now. The Microservices book is forthcoming circa February, most likely. All right, let's talk about presentation resources. I see a couple people like taking pictures of slides and whatnot. You don't have to do that. I've posted this slide deck on SlideShare. The only URL you really need to remember is the first one, and you don't even really need to remember that. If you type Derek Ashmore Java or Derek Ashmore SlideShare, it'll come up. All these links are active. Most of the samples I'm going to draw on are open sourced and on my GitHub. And I do have, this talk is a little bit more higher level, but for people who want to get down and dirty into the code, I do have a sample microservice written in Java, and that's also posted on my GitHub. Basically, I see people taking pictures. Beyond this slide, you shouldn't have to take pictures. It's available. Let's talk about the agenda. I'm going to have a short definition section up front for the people who didn't raise their hand in the first question. And then we'll talk briefly about why we get into microservice architectures and why you might want to use that. I then go into design considerations. All right. Yes, we have coding patterns. We've got coding patterns for everything under the sun. Microservices is no exception. There are dozens of them out there. I don't have time for all that, so I have cherry-picked what I consider the most important, and that's what I'll go over. That being said, I also have links to additional reading at the end of the section so that you can pursue this, pursue some of the other patterns if you like. Then going to talk about cross-cutting concerns. I'm talking about things like monitoring some of the things we get into with microservices, tracking transaction IDs, security. Some of those things that are specific to microservices are where microservices tends to change how we approach those versus traditional web application architectures. We'll get into in that section. Every paradigm comes complete with marketing fluff. Hint, microservices is no exception. In the when to use microservices segment, I'll try to separate the wheat from the chaff a little bit. Tell you what's marketing fluff, what isn't, and you're going to find out that to get the benefits of microservices architectures, there's some fine print you need to observe to get those benefits, and I'm going to try to tell you where that is. Then we'll have some summary and some Q&A. Okay? All right. The short definition section, to irritate everybody who didn't raise their hand, basically microservices has no real concrete definition. As geeks, we like concrete definitions. Microservices doesn't have one. The way to think about it is services that adhere to some characteristics. And there are exhaustive lists out there. I've kind of narrowed it down to the few I consider the most important. And by far the most important is microservices basically fill a single functional purpose. By functional, I mean business. They do one job, and it's business specific. They do one job, they do it well, and they don't do anything else. All right, they're very focused. Analogies that people draw on are Unix utilities. For instance, ls, the file list utility, lists directory entries, be they files or directories, and that's all it does. Lots of options for formatting, but it does one job, does it well. I prefer as an analogy to use my stereo system, even though it's hardware. It illustrates some other points. The idea is that in my stereo system, if I swap out my speakers, none of the other components care. All right? Microservices is the same way. You're supposed to be able to swap out one microservice for the other, and they're supposed to be self-contained enough that none of the other services need to care as long as it did what its predecessor did. So microservices aren't dependent on an execution context. They don't care whether they were initiated by a user in a web app someplace, or by a batch job, or by some sort of mule ESB flow. They don't care. If they get their instruction, they have their resources, they do their job, that's it. Basically, it keeps them very loosely coupled. They run as an independent process, all right? In some shops, it's common for licensing considerations to bring up multiple web applications in one container. Microservices, you typically don't do that. It's basically an independent process, independent JVM. And it typically uses a standard interface. Most people use Web Service REST, but that isn't strictly required. What's more important is that the interface is standard, and everything uses it. Okay. Microservices, normally people don't start out with developing an app and using the microservices architecture. What usually happens is a traditional web app gets too large and too complex to maintain, and they start breaking it up into smaller services. And that's usually where microservice developments come about. What usually gets left as a cohesive unit is the user interface. There's a business reason, business advantages to the user to have a cohesive user interface. Web frameworks are notorious for not playing well together. As an example, let's take Java server faces and Spring MVC, both viable web frameworks, but try to combine them, and you'll quickly find out that you're going upstream, swimming upstream. So usually you leave the presentation layer alone, and we're going to talk a little bit more about that later in the program. What's important is that instead of that presentation layer basically using database connections to marshal data from databases and that kind of stuff, it farms all that out to your microservice library. All right, and each one of those microservices are independent, and to be independent and not coupled with anything else, they have to have their own database, which is another kink that, as an ex-DBA, that's the hardest part of this pill for me to swallow. But essentially, it's recommended in a microservices architecture that basically each service has its own data store that it and only it uses. Now that gives you a problem, all right? Most organizations have data that's common throughout the enterprise. And I'll give you an example. I spent several years in the higher education market. Anything a university does, any university-built system has to have a knowledge of what campuses that university has. And to deal with that common data, you've got two basic choices in this architecture. One is you write one service to maintain campus information and everything else calls it, or you make arrangements to copy that campus information to the services that need it. I prefer the service call option. That's just me. Most people will be concerned about performance of such a thing, but there are ways to mitigate the performance effects of that. So, and I'll talk about that. All right, let's move on to benefits. Why do this? Besides the obvious indication of modularization, breaking a big problem up into smaller problems. One of the benefits that people go through or go for is the fact that there's very little or there's no technical stack lock-in. All right, if you're organizing services at a service level, it doesn't matter whether the services that you're calling are written in Java 6, Java 7, Java 8, Java 9, or whether they're written in Go, or whether they're written in anything else that you care to write a service for. And what that does is that gives you the freedom to use the technical tools that a particular service needs with no impact on everything else. Try doing that contrast that with what happens in a very large traditional web-based application. You want to upgrade from Hibernate version 2 to Hibernate version 4. You can see that the ripple effects on your code base are going to be fairly significant, and that's not a 20-minute kind of a conversion. In this world, you can more easily upgrade what a particular service is using without affecting anything else. That said, just because that barrier has been removed doesn't mean you want to go crazy. Organizations have economies of scale interests, right? It's easier to support 3 database platforms than it is to support 20. Right? So just because you can choose anything that you want doesn't mean that you should. Anything that you write, somebody's probably going to have to come along and maintain it. So it makes sense to be smart about the technology stacks that you pick, but this constraint that was there under traditional web-based application no longer is. There's some fine print to get to it, but one of the benefits that people go through or go for with microservices is higher throughput, higher velocity. All right. The idea is that since you're breaking up the work into small independent problems, you can basically set a small number of developers on each service, and because they've got such a focused target, they don't have to talk to anybody. They're basically heads down development. All right. So the communication overhead that you get with large traditional web apps, as far as developers arranging, coordinating their changes with umpteen zillion other people, that doesn't necessarily happen in a microservices world if your service boundaries are drawn fairly well. So that's one of the benefits people go for. Let's move on to design considerations. Before I do that, for the people in the room, any other remaining questions on what microservices are? Yes, sir.
So you could still have your system broken down into microservices, but for operational convenience, it might make sense to bunch up a few of them together into one JVM. Is that not?
No. Okay, the question was for the people who are attending via streaming, wouldn't you go for the convenience of bunching several microservices up into one JVM? And that defeats the purpose of microservice architecture. That by definition ties them to one particular version of the JVM. If you want to upgrade from version 7 to version 8, any microservices bundled in that JVM would be affected, right? Same thing happens as you get effects from other services. Something goes awry in one of those services in the JVM in that scenario. It's possible that other services besides the one that's having the problem get affected, right? So you really don't want to do that. Later in the program, we're going to talk a little bit about packaging options, about how to make it easy to publish an individual microservice in one JVM in one process. There are tools to do that. Okay?
A sort of related question, quick one.
Okay.
You said it should be broken up into business functionality, right? Basically,
Mm-hmm.
So it's okay, I guess, to say that you could have two different physical services part of the same functionality within the JVM. By physical, I mean, I don't know, one is a REST service, one is a SOAP service, where they're solving the same business functionality or serving the same business functionality. Yeah.
If you want to put multiple contracts to the same service, you can do that. Typically, people don't. But yeah, I don't see anything wrong with that. But yeah, that's the question was, and my bad for not repeating it, was could a microservice publish multiple contracts? And my answer was, of course, that you typically don't, but you can. All right, I'm going to go on so that we don't get caught short on time. Design considerations, I'm breaking up into 4 basic categories. I'm going to talk about service boundaries, and by that I mean figuring out what this mission statement for a microservice should be. Turns out that's deceptively hard. I see development teams basically agonizing over that, so I'm going to provide some guidance on that. Service call failure. In a world where a user action could lead to a microservice call, calling other microservices, service call failure or calling a service that's not up is a very real possibility, and there are some ways we can mitigate that. Data integrity, we're all used to in traditional web application architecture. The safety of the database transaction, exception happens, rollback happens, your data is left in a consistent state. In a microservice world, that's a lot more dicey because you don't have one transaction guiding the entire user action. So there are some ways to deal with that we're going to go over. And then, of course, performance. When everybody first hears about microservices, the first question is, well, doesn't performance suck? And the answer is that there's some ways we can mitigate that. So we're going to go through some of those. All right, service boundaries. I kind of break down the kinds of services into 2 main categories. One I'm calling core services, basically CRUD-like features. Let's take a higher ed example. Sooner or later, a university has to record the fact that student John Smith is attending, and this is his address, and this is his name, and these are the particulars about him that we care about. Sooner or later, that's got to make it to a service that stores that somewhere in some type of database. That CRUD-like service I'm calling a core service. It basically records facts. Process services basically address complicated business processes that typically rely on other services to do their work. And I've got some higher ed examples like processing student applications or debt collection for deadbeats or whatnot, or doing something like disciplining a student or recording, producing transcripts, things like that are more complicated and typically involve multiple services. I'm calling process services. Partitioning is an art to some extent. If you break your services up into too few, you've got a baby monolith problem where each of the services are smaller than the traditional web app they came out of, but not really small enough to give you all the benefits from microservices. But if you have too many or the service calls are too fine-grained, then performance becomes a problem. So given that I've told you partitioning is an art, and I can't give you a heuristic for determining a mission statement for a service, what good am I? So I can give you a couple of boundary checks, all right? One is that each microservice, you should be able to express its mission statement, the business that it does, in one sentence in business terms, all right? And I've got several primitive examples up here on the board. But but the idea is that you don't want a microservice to have a technical function. If you're going to create a microservice to maintain the foo file, well, the foo file might have some sort of business impact somewhere, but that sounds more like a technical concern to me rather than a business concern. Okay, so that's check number one. Check number two, when somebody shows up and they want to call your service, do you get nervous? Do you start asking questions about, okay, what did you call before you calling my service? What are you calling afterwards? Those are all red flags that say that you're not truly context independent. You actually care about what services got called before you get called, and you care about what services, you're making assumptions about the execution flow of multiple services, and you don't want to do that. The whole idea here is that microservice architectures, basically microservices are supposed to be self-contained and independent. Warning signs here, people who are spend time analyzing call flows. Like, well, you know, if I call this service first and I gather this data and I can pass it on to this other service and I can pass it on to that other service, and those are all indications that your services aren't really independent, and they should be. Okay. We do have something that's unfortunate with microservices, and this obsession with size. The phrase micro basically means that, or implies to people that microservices have a small code base. The point I'm trying to make is microservices are about having a single functional business purpose. They're not about having a small code base. It just so happens that if you have a single focused business purpose, you usually have a smaller code base. It is a byproduct of using a microservice architecture, not a end goal in and of itself. In other words, I see a couple of, I've had a client in the past that basically installed rules that say that, okay, a microservice can't be on, over X number of lines of code, and that's really kind of silly. You need to worry about the mission statement for the service, not its size. Designing for failure, okay? As I alluded to earlier, we don't necessarily have the safety of a database transaction rollback. If a user takes an action and that goes through 10 microservices, and the fourth one, the first three go completely successfully, and the fourth one bombs, potentially your data is left in an inconsistent state, because each one of those services has different database transactions associated with it. There's no universal rollback that magically puts everything back. So there's some, first thing everybody says is that, well, you make everything clustered, right? So nothing can be down. Well, the reality is that there are cases when an entire cluster for a service is down. It could be that it's being upgraded. It could be that some resource it depends on isn't available. So none of the nodes in the cluster work. So in other words, clustering isn't quite enough. There are some coding patterns that we can use to help mitigate this. And I'm going to go over some of them. First one is the retry pattern. All right. They call this the retry pattern, but I call it insanity, because you literally are doing the same thing multiple times and expecting a different result. And the idea is that whatever, let's say an initiating service requests something of a target service, the retry pattern basically just retries it at a specified interval until it eventually succeeds. The idea is that whatever took down the target service is a temporary condition, and someone's going to come along and fix that. All right. Couple of configuration options. This algorithm usually has a max number of retries. You don't want to retry forever, right? And the other configuration option this pattern usually has is the interval between the retries. If you give something 50 retries and it does those 50 retries in 10 milliseconds, you haven't really created enough of a window for somebody to restore service on the target. So that comes into play too. I've got a sample retry implementation on my GitHub. However, there is tooling support for this. Apache CXF supports the retry functionality. Spring Batch has a retry template. And Apache HTTP client supports it as well. And I've got links to an example there. Circuit breaker, all right? This pattern is patterned after the junction box in your apartment or house, all right? Something bad happens in the electricity and the circuit pops or the circuit trips and is open, and basically nothing on that electrical circuit works. This is a software version of that, all right? The idea is that the circuit breaker, after a configurable number of exceptions from the target circuit, basically just short circuits it, doesn't allow any calls to the target service to go through. It errors out immediately. Now, why is that important? Everybody here, I'm sure, I don't even have to make this a question. Everybody here has surfed to a site that's unavailable, and your browser waits for 60 seconds or 90 seconds or whatever it is to eventually tell you that the site's down. The same thing can happen in a service call scenario, right? Now, you may configure different timeout periods, and you may not be waiting for the 90 seconds. You may be waiting for a shorter period of time. But you can see how in a microservice world where you have dozens of these things, a problem with one microservice can bubble up to other services. Suddenly, some service that's sized to host 10 concurrent transactions now has several hundred times that because they're all waiting for this timeout period, right? And so you start getting derivative resources. Everything on the planet starts coming down. So it's important, if your resources aren't there for your service to do its job, airing out more quickly is better. It's an interesting twist on performance tuning. So basically, we hinted at the number of thresholds. Common thresholds on this pattern are the number of errors required to trip the circuit, all right, and then the amount of time required to attempt a retry. Basically, this pattern has Hystrix support. It's the only product I found that formally supports the pattern. If you're already using Hystrix, by all means, follow the link, and it takes you to a description of how to use that feature. That's a very heavy product, so it's not worth bringing it on just to implement a circuit breaker pattern. I've got a sample circuit breaker implementation on my GitHub that you can use, copy, whatever. And I've got more information in the link at the bottom. Dispatching via messaging. All right, we do this in traditional web applications today, right? Essentially, the idea is that target instead of calling a target service directly, you put instructions on a queue, and something reads that queue and processes the work. And the idea is that if the target service is down, the work just stacks up in the queue, and then when somebody restores the target service, all that work just gets processed and life is fine. Basically, there's tooling, lots of tooling support for this. This isn't a new concept. We do this today. The JMS API is very easy. Most people use it directly, but for producers, you do have a JMS template and a Rabbit MQ template, but as tooling support. But this is old news. Service call mediator. All right. This is the idea that if one of your dependent services is down, depending upon the importance of that service to whatever business function you're doing, maybe you can provide partial functionality. All right. we've all seen this from different websites. For example, I logged on to my bank a few days ago, and it told me I couldn't transfer funds, but I could do anything else. All right, so the idea is that sometimes you don't want to abort the whole show just because a dependent service is out of commission. So the problem is, how do you mediate that? How do you codify that? No one wants to write schizophrenic services that have to start wondering about, well, okay, if this thing is up or if that thing's down. You want to localize that, and that's what the service mediator does. The idea is that instead of the initiating service calling the target service directly, it calls the service mediator who makes the call. If there's an error, he basically does any logging that you want to do. He creates it, issues any alerts to admins that the service is down that you want issued, but he returns the default response to the caller. And the default response could be, an empty list or something like that if it was a lookup or something along those lines. And the initiating service just basically processes as normal, doesn't even know that the dependent service is out. That's all localized in the mediator. And there's an example implementation on my GitHub.
Can I ask a question about that?
Sure.
So just make sure we understand ourselves. If I have 5 different clients, all that call the same service, each of them will have their own copy of that mediator.
That is correct.
And if I upgrade one of those and I upgrade the mediator, I probably don't want to upgrade the other 4 because they're all independent.
Well, okay. The question is, if you have a mediator in several different services and you upgrade the service mediator in one, the inference is, doesn't that really break the microservices architecture? Because the idea is that any change you don't want to affect multiple services. The idea is you treat the service call mediator just like any other common code. Any microservice that you write in Java is going to have dependencies, right? Apache Commons Lang, just a second, sir. Whatever it is, bean utils, whatever it is, it pulls in. Each service should make a decision about when to upgrade their dependencies. And the service call mediator is no exception to that. All right, so what I would do is I would make the service call mediator common code version it. So you've got mediator version 1, mediator version 1.0.1, and so forth and so on. And individual services make the decision as to when they're going to upgrade. Okay, all right. Okay, I'm sorry, sir?
But would it, the impact on the initiator could be different depending on systems. One initiator may say, oh, I'll just ignore that. Other one may say, I can't do anything. So would it really be dependent upon the implementation of the mediator, be dependent upon the initiating service?
I've drawn these, yes. Essentially, what the question is basically, wouldn't the service call mediator have to do different things depending upon which thing called it? And I'm thinking of the service mediator as code in the initiator service. So the initiating service has context. It knows how important that call is and whether or not it can do business without it. All right? And so the services that could make use of a service call mediator would employ one. The services that are completely out of the boat, if that target service isn't around, would just simply not use it. All right, that's the answer. Okay, moving on. Designing for performance. Microservice architectures greatly increase network traffic. All right, they're a lot more chatty. Basically, there are ways to mitigate that. Everything you've learned with SOA about trying to make services more coarse-grained as opposed to fine-grained still applies, but there are some other patterns that we can use to mitigate that, and I'm going to go through them. The only one that's designing for performance that I'm not going to go through is dispatch via messaging. Essentially, that increases performance by giving the users the illusion that something's faster, but in reality you're just taking the work offline. And since we already talked about that pattern, I'm not going to talk about that again. So back ends for front ends. It's common for web apps to basically consolidate microservice calls. And I'll give you an example. Rumors are that when you surf to Amazon.com and it comes up with that first screen, that the data for that page is actually obtained by multiple different microservices. And I can guarantee you that your browser isn't making dozens of calls to individual microservices. What's happening is it's making one call. Something on the other side is taking that user action request for the display, calling whatever myriad of microservices need to be called to gather data for that display, combining the response and sending a unified response to the browser. The idea is that you keep that network chattiness of your microservice library on an internal network that you control and that your network engineers can performance tune, right? You don't expose it to the web at large. Another name for this is a name I don't typically use. Another name for this pattern is called the API Gateway pattern. I don't use that name because people get it confused with API Gateway products, all right, like WSO2 or Business Base or something along those lines. Those are more for governance. I'm talking about the pattern, okay? Anyway, we've already talked about not exposing microservices directly to the browser. Then we're on to a pattern that I basically use in traditional web apps as well, and that's expiring cache. The idea is that all organizations have some data that doesn't change very often. Okay, in the case of a higher education example, campuses. Right? It's a rare day when Indiana University, which I came from, establishes a new campus or closes down an old one. But that list is needed for just about everything on the planet in a university setting. So the idea here is you trade memory for speed. The first service that needs to know of the list of campuses that are out there and some information about it, that data gets read and it gets cached. All right. Every other subsequent call for that information gets served up from cache. All right, and you can do that because campus is such a static data. You don't want to use it for things that change very frequently. All right, but you can safely use it for things that don't change very often. There are a couple of gotchas with this. Typically, the cache is employed on the client side, not on the service side, because the whole point is to eliminate the network call from the client to the service. So essentially, if the day comes where a new campus is established, services using an expiring cache mechanism will learn about that new campus at different rates. So you could have a small period of time where you get different answers from different services. But beyond that, it's a very effective tool. There is tooling support for it. I prefer Google Guava, but I don't want to start any religious wars. If you're an cache fan, or you're a Gemfire fan, or a fan of anything else that supports an expiring cache mechanism, use it. I'm promoting the pattern, not necessarily the tool. All right, designing for integrity. We've talked about the fact that we don't have the safety of a database transaction, and unfortunately, we've got a pattern to deal with it, but it's fairly labor intensive. And the idea is to write a reversing transaction. So the idea is, and this is an example up on the board, that say a microservice needs to issue several calls to do the work that it needs to do. The first one works. The second one fails. And in that case, instead of just blowing up, the initiating service initiates a third transaction to reverse the first transaction that succeeded so that your data is left in a consistent state. Now, this is laborious, and there's very little product support that you can apply to it because it's so custom to what you're doing. That's, so that you want to make decisions. Your two basic choices are, when something fails, have a developer go out and fix the data into a consistent state, figure out what's inconsistent, and issue whatever transactions they need to make it consistent again, or you write some sort of reversing transaction type logic. And the way you do that is you make those decisions is you just frequency of occurrence. For something that fails, like maybe once or twice a year, you don't bother writing a reversing transaction for it, right? You send somebody out to manually fix it. If something breaks dozens of times a day, yes, you'd try to make it not break dozens of times a day, but you might consider that as a candidate for codified reversing transaction. All right, we've talked about most of this. I've got a link to more information about this pattern in the slide. Let's talk about some other ancillary concerns. I'm sorry, yes, sir?
How do you deal with failures in the initiator of the transaction while the transaction is in process? So you lose the fact that a transaction has partially succeeded.
Okay, the question is, what happens if something happens that we lose the fact that a transaction has partially succeeded? And a way that can commonly happen is in the way, let's say something takes down the initiating service between transaction 1 after the error and before transaction 3. All right? That's a possibility. All right? That's something that would have to be manually fixed. All right? That comes under the manual camp. I can't think of a way to codify a reversing. Well, I suppose I suppose I need to think about that a little bit more. But you're right. That is a potential weakness in the algorithm. Okay. Yes, sir. Okay, the question is, don't you have the same potential problem in a normal transaction without an exception, because something could take down the initiating service, say, between transaction 1 and transaction 2 and transaction 3. Have I got your question correct? Right.
And then you have commit, and then the third resource. I want to go back. It's perfectly okay. Then you're in a heuristic state. It's not a new problem just because you're dealing with microservices.
Right. Okay, so the suggestion is to utilize two-phase commit instead of a. Okay, the statement is that potentially in a microservices architecture you could have this same problem even if there wasn't an exception, because if something took down the initiating service or something, the last transaction in the chain decided to blow up, you could basically have this same problem, and I agree with you to some extent. If you want to talk about this further, we can talk after the presentation, but in interest of time, I want to move on, if that's okay. Yes, sir.
So to that point, right, you can lose the fact that you edit out partially in the transaction. Would it make sense to pipeline them? So target service 1 would call service 2, maybe through JMS in between, which can be transactional. Like, is that a microservice pattern or acceptable one?
The question is, wouldn't this be a candidate for some sort of messaging flow where each service is a node in that flow? Typically, that's not done with, I suppose it's technically possible, yes.
It's not, like pipelining them isn't against any of the good practices you mentioned about microservices.
Is pipelining them against good practices. The only one I can think of that it would be against is the context independence part. But then if that pipeline serviced a complicated business transaction, then yeah, I could see uses for that. Okay? We've got about 15 minutes left, so I'm going to move on. We inadvertently covered this slide previously with the question about common code. The secret is to version it, let services decide when to upgrade, and you can't put anything in common code that if a bug is found or if it changes, forces a redeployment of several services. That breaks the whole paradigm. All right, so I'm going to skip past this one. Let's talk about cross-cutting concerns. Microservices, okay, we're going to talk about deployment, transaction tracking, security, and contract testing. There are other cross-cutting concerns that are very important, but the way we deal with them in a Java world doesn't really change between microservices and traditional web application architectures. So I'm going to talk about the first 4, and the stuff that's the same, I'm going to assume that you do that today anyway. Deployment. Microservices are deployed as a single process, all right? And it turns out that we've got a large number of tools that will help you do this from a Java perspective. Spring Boot and Drop Wizard seem to be the 2 most popular, but there are a whole host of others out there. If you're using one of them, please don't kill me for promoting one of these 2. I'm not interested in getting in a religious war, but the idea is that both these products basically take your application and an associated container, typically Jetty, although Drop Wizard, Spring Boot supports Tomcat as well. Basically combines it into an executable jar. All right, so it's very easy to establish it as a separate independent process, just like microservices are meant to be. Docker, which I'm sure you've all heard of, basically takes that one step further. And if, to execute a jar, you need a JVM installation and whatever the JVM needs to function. Docker takes that a step further and allows you to deploy the version of Java you're running under, as well as your application fairly easily. In another version of this presentation, I go into this in a lot more in depth than I have time to here, but I've got a sample on my GitHub of a Spring Boot, a Drop Wizard, and a Docker deployment. So for those that want to get into code level stuff, there's something for you. Correlation IDs. In a traditional web app, transaction fails. Typically, all the information about that transaction and what sourced it is available in the application. In a world where a user action might travel through many different services, for support reasons, you need to be able to associate. This service call was, the same user action as these other service calls from different transactions for different services. And the way you typically deal with that is arrange for each user action to get assigned a correlation ID of some unique ID of some sort, and you arrange to pass that in the header to any subsequent service requests, and you arrange in those microservices to include that header information into any microservices calls that it makes. And you combine this with logging features that'll make sure that transaction ID comes out in the logs of, basically every service call that transaction goes through. And then when you pull those logs together in Splunk or Logstash or whatever log management system you use, you can do a search and you can pull up any transaction that pertain to a particular user action. How we deal with that in Java is typically with some sort of servlet filter. And there's a code example on my GitHub. Spring Boot support has been requested for this, but it hasn't come to light yet. All right, let's talk about microservice security. All right, I look at security in terms of levels, all right, or layers. The more layers of security you put on, the more secure it is. End user level security, same way that you govern it today. No differences. As far as what I'm talking about now is basically security for individual microservices or for your microservice library. And I think of that in a couple of different layers. The first and easiest layer to install and implement is just basic network routing enforcement. All right, limit in your microservice library layer, limit that access only to within the firewall, limit it to series of application servers and whatnot that need it, limit access to specific hosts and subnets so that people can't, just decide from their desktops to call a microservice in production without having authorization to do so. And that's the easiest thing to do. And that'll take care of some part of your requirements, but not all. There are still services that are more sensitive than others, all right? So for instance, a service to list, a service to manage university campuses is a lot less sensitive than, say, some sort of payroll service. All right, so you might need additional security for individual services that are dealing with sensitive data. And my advice there is to issue service accounts for them and treat them basically like database resources. If you think about traditional web apps, you use service accounts to connect to your database, right? Microservice libraries are no different. In other words, what I'm trying to tell you is if you propagate end user security back to your microservice layer, and a microservice has to worry about whether an individual who's at the other end of the chain has authority to do what they're trying to do, that basically is very complicated. It gets very complicated very quickly. So treat microservices like you treat database connections in terms of security is what I'm suggesting. Contract testing. All right, one of the ideas in microservices is that you can switch out one version of a microservice for another version of the same microservice. In other words, the idea is, all right, you come across a microservice, you need to make a change to it, and the guy that wrote it, or the girl that wrote it, basically, it's hard to maintain, you'd rather just replace it. Well, if you're going to replace this microservice, it better do what its predecessor did, obviously fixing the bug that you're trying to fix or making whatever change you're trying to make. But the safety mechanism here is contract testing. Okay, so basically to the degree to which you've got a rigorous contract testing architecture in place, you can more safely switch out services. Some people are starting to do consumer-based testing. So if I write a service that relies on 4 other services, I basically write a test for those 4 services, the functionality of those services that I use, and so that I know that when they break. That's gotten a little bit of play in the last few months, but hasn't really taken a hold of yet. Tooling support, there are lots of tools to support this. I primarily use HTTP client and SOAP UI, but I'm sure there are others out there. Okay, when to use microservices? Basically, no one starts out with microservices, or at least I can't find a case study published out there where somebody started out with a microservice architecture to begin with. Everything that I've run into, they started out as a traditional web app that got out of hand for them to maintain, and they refactored into microservices. So that's what most people do. And what I'd like to point out is that microservices architectures aren't all or nothing. All right, there is nothing that says that, okay, if you've got a big monolithic web app and you want to break a couple of complicated pieces out into smaller services, you can do that. You don't need to bite the whole apple and convert the whole thing to microservice architectures. Basically, traditional web apps and microservice architectures can live together. All right. Warning signs that an app's too large. I'm sure everybody's worked on one of these, right? You know, you run into the unintended consequence problem where you change one thing and you break 3 other things. You know, everybody's had the displeasure of working on one of those. Basically, that's a sign that maybe the app's gotten too large and it needs to be broken up. And I've got several other points there. Common mistakes. Inappropriate service boundaries. Service boundaries that, service mission statements that basically depend on a specific call sequence or call context, or service boundaries that are not effectively loosely coupled. Not recording all requests and responses. When it comes to support, most developers spend more time localizing the problem in a microservice architecture, so they really do need access to requests and responses, and it needs to be searchable so that they can quickly localize where a problem with a particular transaction is happening. I go further in exceptions that I throw in a Java world. I also include the SOAP request and response for remote service calls that I make that fail. And while typically a developer can eventually get that information, the game is saving time, right? From a support perspective, the less time you spend doing support, the better. The more time you spend on other productive things. Contexted exceptions in common slang, which I use quite a lot, make that very easy. Going right along with that, not checking arguments up front, all right? What happens if you don't, and it's less code if you don't, I see why programmers do it, but the problem is you're just kicking the can down the road. Derivative exceptions and things like null pointers, because you weren't passed all the information you were supposed to pass or get passed in an instruction, those take longer to debug and longer to fix. So in my development teams, when we come across a null pointer exception, to my mind, you've got 2 defect tickets. One is to fix the problem that caused the exception. The other is to properly document the exception so that, you know, it's very obvious what was missed. Okay. No change in governance. The processes that you put in place to manage migrations to deployment. Every business has some process, right? You have to fill out some sort of request ticket. You have to pass some sort of testing hurdles, whatever that process is. To get from development to production, you have to go through it. A common mistake that I see is that you don't have changes in governance that really accommodate microservice architectures. The processes that work for a handful of deployables might not work for 200. You see what I'm saying? It might just be too laborious. So generally, And this could be a subject of a whole other talk, but basically, microservices need a quicker and easier path to production. They need automated deployments and backouts. The less manual intervention, the better. And this is kind of where microservices gets into the concept of continuous delivery and DevOps a little bit. And in fact, those concepts go hand in hand. Further reading. Matt Stein publishes a reading list on microservices, and he keeps it up to date, and it's very good. I recommend perusing it. And at a Java conference, I can't believe I'm actually recommending a Microsoft reference, but credit where credit is due. They call them cloud design patterns, but it's very well written and very concise. So I give you a link to that as well. I've got a Java microservice example on my GitHub that you're welcome to take a look at if you want to get at a code level. And this slide deck is on SlideShare, so there has to be questions. Anybody have any? Yes, sir. I say yes, ma'am. I'm sorry, I couldn't hear you. I apologize. And I'm aggravating the cameraman because I'm stepping out.
That's all right. I think you guys are, it's two, yeah. You guys can stay, it's just that the broadcast is at two.
Okay.
Yeah.
All right. Thanks for coming, everybody. And I will be around for other questions.
Oh yeah. It's all up to you. Good intuition.
You can hang out if you want.
All right. I think I hear some sound. Yeah, we're live. It's amazing. I think there was something like 80 or 90 people registered for this, but it appears that Jason and I can't compete with free beer at Duke's Cafe. So
there's free beer?
You see? So we can all cancel this thing and just go to Duke's. Maybe that's the better approach. So we're going to talk a little bit about the mobile platform, and I think there's a key word in here that I probably should mention in front of mobile platform, and that is enterprise. How many people here work for a company that's larger than 100 people? Yeah, okay, so you're all in the right place. How many people here are mobile developers writing apps for mobile devices? Only one or two of you? That means that only two of you are in the wrong place. So lock the doors now. Don't let them out. we're going to talk a little bit about the server side, really, that hosts mobile apps, if you will. And you'll understand a little bit more about what that means. Third question, not necessarily my last. How many people here have heard about MBAS? You see? You're at the perfect talk. This is what we're talking about. And MBAS stands for Mobile Backend as a Service. Mobile Backend. So we'll be talking about mobile backends. Who knew that mobiles had backends? I know. So to start off with, we'd like to kind of motivate this a little bit at the beginning by saying that mobile devices are ubiquitous. I don't know that I'd have too much argument from any one of you about that fact. As I, earlier on in my life, as I saw some of these devices start to emerge, I always told people that I was going to wait for the device to do everything. I didn't like having a device, a phone, that did some things, and then having a laptop that did other things, and a planner. Back then there was these things called Palm Pilots. Does anybody remember Palm Pilots? Yeah, that was the organizer. That was the electronic organizer. I'm like, I don't want to buy a Palm Pilot. I want my phone to do all of that stuff, and I want my laptop to do all that. So I was holding out for the one device to rule them all. Well, I was partially right. There was some aggregation happening. You know, phones can do a lot more. Laptops are good. But, you know, I was wrong, really, when it comes down to one device to rule them all. There isn't. There are devices that are special purpose, and we all pretty much accept that. Most of us, well, when it's very, let me say that as we hang out with geeks, it's not uncommon for us to go to a meeting and have people lay down their laptop, their tablet, and their phone, and maybe their watch or whatever else that they have beside them, and kind of have this array of devices before them. And then, of course, the problem becomes, how do I synchronize and blah, blah, blah. But the fact is that we expect to use certain devices for certain things. And devices have become a little bit more specialized, especially as we look at wearables and what they're supposed to be doing. We have these Fitbits and other kinds of devices that kind of do specific things. And we accept that. Not only do we accept it, but we expect it to have an experience to match its purpose. We expect the device to support us in a way that is appropriate for what we bought it for. And chances are we spend a hunk of money to buy it. We want it to do it well, to feel natural. So the two things that we're getting out of this slide here is, one, devices are everywhere and of all kinds, ubiquitous. Secondly, that there's a whole bunch of context associated with each of these devices. And the context is device specific. With that in mind, let's move on just past that to the challenges that exist right now in having an enterprise mobile strategy. What is an enterprise mobile strategy? Well, that is enterprises attempting to host a lot of their applications on mobile devices of various sorts. And the challenges, well, they start with, how do I integrate these applications with all the different backends that I have? As a company, I have lots of data. It may exist in some legacy type of really hard to get place. It may be a relational database that is relatively easy to get to, or it may be some sort of, you know, ERP. There are various types and flavors of how enterprises store their data. But in the end, that's what the applications have to access. So trying to integrate all the various applications that they want to sit on the mobile devices to these different types of backends can be quite challenging. And not to mention repetitive. You know, if you have to do the same amount of integration work with all of the different mobile applications as well as the different backend data sources. It turns out that the biggest concern that most IT organizations have and most corporations have with mobile strategies is security. Who'd have thunk it, right? I mean, this is the biggest asset, is their data. And they're very, very worried about that data getting out. It's easier to protect the data when it's sitting in a lab on a server with a bunch of fans burning around it and the door with 5 locks on it, and only people with gray hair and beards able to get into that room. But it becomes a little scarier when your data is accessible by any mobile device that someone might happen to leave at a security counter going through an airport, or that somebody may have left on a tablet that they put down on a park bench and walked away from. So this is sort of part of what really worries IT people in the corporation, is this notion of security. And that exists at multiple channels. These things called mobile application management, mobile device management, we'll talk about those later on. And then, of course, there exists the decision-making process of, well, what kind of devices do we need to support? How do we write these apps? If we're writing for a phone, do we have to then write this app for iOS as well as Android and perhaps even Windows and who knows what else? Well, the kind of decisions then start to propagate onto themselves, and you end up with a morass of problems. And to kind of add to those problems, you have the whole problem of process management. And the problem is that most of us, as soon as we get going in a certain process, then we're comfortable with that process. We don't want to change. We'd rather not change. And when you have a large corporation, you not only have a bunch of people that are using some of the same processes for a long time, but you have lots and lots and lots of those people doing that same thing. And it's very difficult sometimes to get that to change. And we work for Oracle, which is a pretty large corporation and has a whole bunch of processes in place. It was pretty difficult for us at the very beginning when we went to suddenly go from packaged applications that we put on CDs and give to customers to cloud-based applications that we have to host in cloud services and on virtual machines and data centers. This is quite substantially different, and the release process was substantially different as well, going from releasing to a product once every two or so years to perhaps every month. Right, so this was huge for us. And then everybody always wants it to happen yesterday. It has to be very, very fast in terms of development cycles. The mobile apps have to be updated quickly. The maintenance has to happen right away. Everybody's expecting things to happen now, right away. So this has to be incorporated. And this all makes mobile a little difficult for people that are just getting on board.
We'll take a quick look here at a fairly straightforward client application that I'm sure a lot of you have probably seen something very similar. Typical HR application. Got some of your employee information about maybe their last evaluation, where the office is, stuff like that. There are a lot of different pieces that make it up. It looks pretty straightforward, pretty simple. When you take a look at it and start looking at where all that data is actually coming from, it's not coming from a single location. There are a lot of places where this is potentially being stored. You might have some storage in the cloud where the profiles are being kept. The HR information might be on-premise in your core HRM system. All the social media stuff, that's all out on the web. You're going to have to go out and reach out to get that information. The evaluations that I talked about, your last set of evaluation, you might have talent management. You might have purchased a cloud service where that's coming from. Google, that's out on the web. All these pieces are all from different back-end systems. So all of a sudden, this simple app, thinking to yourself, yeah, that's pretty straightforward. I could write that. The GUI isn't too complicated. A bit of data on there. I can handle that. It gets complicated really quickly when you look at where all the information is coming from. And you really want to foist that problem on your mobile application developers. There's a couple of guys in here that said they did the mobile app development. I don't think they want to deal with all those problems trying to integrate with all those systems. It's bad enough they have to worry about their client dev tools. What am I going to use to write my application? What type of application am I writing? You don't want them worrying about all the other details. Mobile services, when they're doing push notifications, you want them to worry about when they're doing it with Apple versus Android. Two different systems. You want them to have to know all the details of all the different providers. Skip over to the integration. Mike talked about that. All these back-end systems using different protocols. They're secured different ways. Some are using OAuth. Some are using key client certs, stuff like that. And then on top of that, you want to be able to monitor and analyze your system. If you've got your client device talking directly to these back-end systems, there's no real way of doing that. You can't store the data on the device, call everybody up, you want to do some analysis. Hey, can I download that data off your phone? You can't do that. You can't store the data on the phone. You can't store all this analytics information in all these different back-end systems. Then you have to write yet another solution to go into all these systems, try and aggregate all that data to actually perform proper analysis of everything. that's where the platform, the mobile platform comes into play. It's to simplify this stuff. Simplify your route from A to B, from the client device to those back-end systems. You want to simplify the experience for that mobile application developer. We'll take a quick look at a couple of different application types. So there's B.
Question. Why would this be limited to mobile applications? Can this be even one of the same issues with web development as well?
It is, and this isn't really, the focus is on mobile because there's mobile features in a mobile platform, but you're right, it's not limited to it. There's a lot of benefits to all sorts of platforms. It could be mobile devices, you can do web development, HTML5 sites, a lot of that comes into play here as well. So different application types. There's B2C versus B2E. Business to consumer, business to employee. The example we just saw was business to employee. Business to consumer is basically your Angry Birds application. You're reaching out to the masses out there. There's lots and lots of users. They're essentially untrusted because you don't know anything about them. Basically no control over the device. You don't know what OS they might be running. You're trying to reach out to the masses, so it could be Android, could be Windows, could be iOS, who knows. You have no idea what version they're running. You don't know what other apps they might have, what other configuration they have. You're trying to reach as broad an audience as possible, so you don't want to restrict it too much. And in most cases, they're going to be anonymous. Like I said before, you don't know anything about them, and when they're accessing your system, you may not have a whole lot of profile information, if any. Often you'll have self-registration so that you can have at least a very basic amount. Just by virtue of them downloading and launching the application, you'll have basic information. If anything, you'll know a little bit about the device, but maybe not much more. B2E, your business to employee type applications, like we saw the HR app, somewhat different, much smaller number of users, typically. You trust them for the most part. These people work for you, so you hopefully have a certain level of trust with them. You'll have a full profile. That information is in IDM. You still don't have full control over the device. I mean, with large companies, you can't afford to buy every single employee the exact same device. So BYOD, bring your own device, is a reality. So you're still going to have to deal with all sorts of devices. But because it's in a B2E type scenario, you're able to add a few more constraints to it. So you've got these applications available for employees to use, and you're encouraging them to use them. You can place some restrictions on being on, say, a minimum OS version, having a particular configuration on the phone, things like that, and that tends to be acceptable. On the flip side, because this is a BYO device, you have to remember we're talking about corporate information. There could be very sensitive data here. So you have to be very careful about how that is stored and what you do in case the device is compromised. Like Mike said, you might forget your phone at airport security or something. How do you deal with that? That's where the MAM and MDM come into play, mobile application management, mobile device management. In a nutshell, if you lose the device, you have the ability to possibly wipe it remotely, or at least keep the data safely encrypted on the device, so if it gets lost, it's not easily accessible. Now we'll move on and talk a little bit more about the platform itself. We'll start at a high level and we'll get down to the features as we go. At the high level, what does it look like? So on the left, you've got your devices. This is the client-side environment. Like we said, any types of devices, you don't really know what you're dealing with. Sorry, brain cramp. Complete brain cramp. It's been a long day, very, very long day. Sorry about that. Like I said, you're trying to go from A to B. You want to simplify the life of your application developer. That part is completely decoupled from the platform. They're free to use whatever tools they want. That doesn't impact the cloud service or the platform at all. When you move up to the top, this is sort of your management layer, the management view on the platform. So where you do your configuration, administration, monitoring. What's important to note about that is depending on the role that you play in the organization or in the mobile space, your view on the platform is potentially different. If you're the web app developer and you log into that, you want to essentially be able to browse and see a list of all the APIs that are available to you to code against. If you're, say, the system administrator, you want to log in and you'll see how the system's performing, if there have been any outages, what kind of throughput throughput are you getting on the system? On the far side are the external systems that we've talked about a few times now already. It could be any type of protocol that you're talking to. That's why the platform's in the middle. You don't want your device having to deal with all the differences there. And that's where the platform, that's why it's there. It's tying everything together, really simplifying things for you. So typically, you're going to have both your top layer and your application, your mobile application developer, when they're talking to the platform in a consistent way. So the standard these days tends to be REST. So when your web app developer is writing their applications, the platform's giving them a consistent view. Everything's REST. You'll tend to give them the same style of APIs. You'll write them that way. Whether they're custom APIs or built-in APIs, it's a consistent view. And that's for the one application. If you're talking hundreds of applications in your corporation, even better. Every one of those apps is going to be consistent. So when you're switching from one project to the next, you don't have to relearn everything. You're always going to have a consistent view when you're accessing those APIs. API management.
All right, how many people here have heard of API management? Okay, roughly half of you. API management is kind of a newer thing with some slightly different packaging, just like everything else in computer science, right? We wrap something up a little differently and give it a new name and it's cool again. Well, API management is kind of like just taking the notion that you want to separate interface or API from implementation. And API managers, and there are a number of them out there that are starting to get big, and you probably saw some of them at the demo grounds. They essentially do that very thing, but they add some features on top. They've separated the API by allowing you to define through some API definition language, and because it's pretty much exclusively REST-based, going into the API manager, then you define it through a RESTful API definition language, RAML or RSDL or RADL or whatever you like. And they support different ones of these. And then you upload these to the API manager, and the API manager then allows you to upload an implementation to fit into that API. And so that the API management layer hosts the implementation. It allows it to kind of, it gives a runtime in which to run. It allows any client, whatever, to call into that API. So this provides the multi-channelness that you want for API managers to support. Any sort of device or channel that you want to access that API can do so. And meanwhile, the API manager supports the authentication and sometimes authorization of that API. So you can choose typically what kind of security model you want, but the API management layer takes care of it for you. And then furthermore, it gives you kind of a catalog that you can browse to see what APIs can I call. What do the APIs do? And gives you this kind of book of APIs that you can use to program your application. And the nice part about API management layers is that they allow you a view to how and who is calling your APIs. They might be called by a given demographic of device. They might be called at a certain time of day or whatever. And these API management layers can kind of help you keep track of these and monitor and measure what's going on as your APIs get invoked. So API managers have become a little bit big right now, and I think for good reason. They're kind of a nice, neat way of defining all of your APIs, and they provide kind of this gateway that you can go through and centralizes some of the logic that you can use by numerous applications. So it promotes sharing as well. Why am I talking about this? Well, because MBAS is kind of like API management, but on mobile steroids. It's essentially taking the API management model, producing something that does API management, but that also provides the mobile features that devices like mobile phones and tablets and things typically need and use. So MBAS is like the follow-on to API management. It starts with API management, and then it adds more to it. Full mobile support. There's a bunch of core services that are available within the API manager part or within the mobile cloud platform. And these are specifically suited for mobile devices. There are things like geolocation, being able to look at the location of where your device is when it calls you. It might be being able to send push notifications and these things. We're going to talk a little bit more about all these features, these core services, in just a minute or two. And furthermore, you want to be able to plug in different kinds of backends of external services that support data and delivery of the enterprise data to the mobile cloud platform. So this pluggability of mobile cloud platform into your backends of whatever they happen to be and wherever they are is very, very important as well. And finally, the analytics of mobile device, of applications that run on mobile devices is somewhat different from this regular analytics of any web app. You kind of are dealing with different things there, and you want to have special support for these kinds of analytics. So these analytics are stronger and more mobile focused than just any regular API manager. Okay, and I promised we would talk about some of these features in a minute or two, and a minute or two has passed. So let's do that. This is a similar slide to what we just saw a minute ago with Jason, and talking about the main architecture of all the devices calling into your back-end cloud service, and then your monitoring consoles and managing abilities all kind of coming in through a management layer, and then finally going out to the data sources in your enterprise at the backside. So the first thing to mention is that on the device side, there, as we said, there's multi-channels, so there's lots of different device types, and each of them kind of tends to have its own way of being programmed, particularly if it's a different vendor. You know, there's different vendors to support different types of devices. And so one of the things that you typically want to do when you're calling the back end is make that as easy as possible. So you want to make it as simple as possible for the mobile application to call these APIs, and it might just be a REST API, but there might be additional information like security and authorization tokens that you need to pass along that way. And so an SDK supports that. But this is not uncommon to require things like this on the client device. I was talking to this JRebel company who's doing something like this. They're putting something on the client device and allowing you to deploy things into their product. And that makes it easier for people to deploy things to their mobile devices. And this is kind of the same thing. It makes it easy to call into the mobile cloud platform if you have this SDK. But the SDK is not required. If you have a regular native application, you just use that to make a REST call to the mobile cloud service, and you're good to go. On the back part, we just generally said back-end data services, but they kind of come in a few different main categories. The first is some sort of cloud service that is probably somewhat related to the cloud service that the mobile cloud is running in. And so it might be like if you're using a vendor, a specific vendor that supports a mobile cloud service, then this same vendor typically will support some other data type cloud service as well. So that's sort of one category, and I think that's pretty standard. The second type is going to be an on-premise data source. So maybe the customer wants to actually talk to a database that's sitting on their own, in their own data center or in their own lab or somewhere that is storing all of their data, and we talked about that being walled off and having some strategy for that. And then finally, you might want to talk to just any random service out there, you know, any custom application or any service that's just available to you. You can call that and get the data back from that. So these are what we call connectors, and the connector is an abstraction of being to call out to this data source somewhere in typically one of those few categories. That's where the data really is stored. You just need to get at it. And the connector allows a flexible approach to getting at that data and reading it back into your mobile cloud service. Typically, REST and SOAP are common ways that you get to these things. They generally have one of these two basic interfaces. There might be other interfaces that you can support, but those are the two main ones that we've seen. And the idea between creating a connector is that it's really about configuration. You're not doing a lot of programming or development to create this connector. You're just configuring it to go get the data from somewhere, and you're invoking some call. So that shouldn't be a whole big process to do. One of the problems that we've noticed in this space, as we did our research in all of this, as we created, and I should have mentioned this at the beginning, that Jason and I, I'm Mike and that's Jason, and we both started working on something completely different. We were on the server side in middleware and in specifications, and we started working on mobile cloud a couple of years ago and didn't know that much about it. And so we went out and did a whole bunch of research and found out about what was going on and what was about to go on. And then we created a product along with some other people on the team. And that is a product at Oracle called the Mobile Cloud Service at Oracle. So that's why we thought we would share the knowledge that we acquired in all of the research that we did. And hopefully you guys can benefit from that. So what we found as we were developing our own product was that there's this problem at the back end with some of these data sources require a stateful kind of session. Right? It's not uncommon to have a session to connect to some of these enterprise data sources. And with a connector or with a stateless mobile cloud service, and they tend to be stateless because they're REST calls going into the API management layer, then you kind of have this issue of, well, how do I maintain this sort of connection, this session that goes from my mobile device all the way to my enterprise backend data source? And so that's a problem that we had to kind of get over. And so different solutions are available in different products that I think you might find there.
So the next feature we'll talk about here a little bit are push notifications. We're starting to get into some of the mobile-specific pieces that you might find in a typical MBAS. So push notifications, messaging, getting the information out to the masses, all the users who have your app installed and are using it. The first thing you want to make sure that your vendor, your MBAS platform provides for you is an API that will allow you to connect to all these different devices, whether it's iOS, Android, Windows. You want them to all be supported. You don't want to be limited. So your API, the API that the MBAS is providing to you, should support them all, but at the same time be generic. Again, pull that problem away from your mobile application developer. You don't want them to know all the nitty-gritty details about Apple's APNS or Google's GCM. Your platform should give you a nice, consistent API that abstracts away those differences so your mobile app developer can, again, focus on writing his mobile applications. When you're pushing notifications, you don't always want to push it to everyone. That's kind of the default position. You can just send out the notification to every user who currently has your app installed. You might want to let them know that, hey, we just created a new version, it's available in the App Store, there's some cool new features in it. You're actually sending that out to absolutely everybody. You also want the ability to filter out those notifications, though. You don't always want to be bugging every single person, because the message you're trying to get out there may not be relevant to everybody. So you can use different filters to direct who that message is getting to. One example is role-based. So if you look at the HR application we looked at earlier, that's the type, B to E, where most of the users you have, as we mentioned, have profiles. So you might associate roles in the system with these different users. So you may send a push notification to all managers, everyone who has the manager role, reminding them that it's time to fill out their employee evaluations. These are due next week. We know you haven't started. Please start now so you can hopefully get them in on time. You can send the notification out to all devices of a given type. So, all the iPhone 6 users, don't put your phone in your back pocket and sit down because bad things may happen. Bendgate. And also do it based on location. If you walk into a particular store, or if you have customers walk into pick your favorite big box store, they've got the application installed, you may want to send a push notification to all the customers who are currently within a certain distance of that store or within the store, letting them know that there's a big sale on socks in aisle 5. Right? So you can really focus the message based on the contextual information that the device can provide to you. Again, there's with the various vendors out there, there's still issues with consistency, the quality of service that they provide, timeouts, retries for notifications getting out there. That again is something you're going to expect from your mobile provider, from your platform, to build into these generic APIs so you don't have to worry about those problems. analytics. I want to find stuff out about my application. You know, it's great, you've built a mobile app, you've got it deployed, you've got people who've downloaded it, they're using it this way, they're using it that way. Well, or are they? How do you know? Right? Once you've got it out there, how do you know how it's being used? Who's using it? Where are they using it? That's the kind of stuff that really gets the business people excited. You know, those are the marketing guys, the sales guys. You know, they want to know that they're hungry for information. They want to know what's being used or how their stuff is being used. So the first part to analytics is actually having data. So you have to gather this data. There are different types or different ways to gather it. The platform itself will typically, or at least it should, be constantly gathering metrics. Every time an API call comes in, it should gather some metrics so you can find out about it. Whenever things potentially go wrong, all the different API types, constantly pulling information that you can use for your analytics data later. And there are custom metrics as well. You can have your application developer triggering custom events whenever things happen. They can do that from either the client side or within custom code, which we'll talk about in a little bit. That's residing on the server side. But it allows them to inject their own business logic, their own sort of personal analytics for anything that is market specific to the area that they're working in. Now the thing about these metrics, these events that we call, that are being triggered, they all have context associated with them. It's not just that something happened. No, something happened, you're miles ahead just knowing that. But with mobile apps and mobile devices, you can get so much more. You can find out where it happened using the GPS information. You can find out when it happened based on if the device has a clock. You can find out if it happened on an iOS phone or an Android phone. You can find out all sorts of things. And as Mike talked about in the initial slide with all these different devices, as new devices come out, the amount of context that you can get with these events is also going to change and grow. You've got all the Fitbit devices. You can envision at a time if you're triggering events and gathering data, you can capture what the person's heart rate was, for instance, whenever they trigger an event. So these events, this triggering, again, is a very important piece of the platform that that they should be providing APIs for you. All right, you've got the data. Now what do you do with it? You want to analyze it. And there's two broad categories of analysis. There's sort of the system analytics and the application level analytics. The system ones are the things that your system admin is going to typically be interested in. Things like, what is the throughput of the system? How many requests am I able to handle every minute? Have there been any major outages in the last little while? Have there been any abnormal behavior? Anything like that. And then on the application side, that's where you're looking at the business guys. They're still looking at the reports. All right, well, is the bulk of my customer base, are they in North America or are they in Europe? You get that kind of information. Are the bulk of my users iOS users or Android users? If you've got profile information, you can find out, are the bulk of my users male, female, if that's been entered? How old are my users? You can find out which APIs are being triggered. So which parts of the mobile application are they actually using? You may see that the APIs related to the first 3 or 4 pages of your app are being hit consistently, but the last page has very, very few hits. So that at least gives you some information to work on. Maybe the access point to get to that page is hidden. Maybe you're not doing a very good job of exposing that functionality. Maybe it's just not popular. But at least then you know. Otherwise, you'd have no idea that that page was never being hidden or rarely being hit. So here's a couple of examples here of analytics that you may typically see. So this is the type of analytics, probably on the I call it on the business side, the active users by location. But this is the type of stuff that your platform can give you for free. Every event that comes in or every time an API is called, the platform can just capture that information as well as the contextual information. When that request comes in from an API to help render some information on the page, information about the device or about the user can all be captured. So you can track over time where your active users are. This is one of the examples we talked about. Where's the bulk of my customer base? You can tell by this, it's mostly in the US. Right, that's the bulk of the users are there, with some up in, I think it's Great Britain up there. So very, very useful information, and this is just one small example. Here's another example, and this feeds more into the custom events. So we often use this, this fictional application called Fix It Fast. It has to do with a major appliance repair company. So your customers can go onto a website, or better yet, use their mobile device, load the application to report whenever they have a problem. Every time that happens, they can capture a custom event saying, you know, a work order has been dispatched. I have an issue. So that's specific to their domain. The other side of the application, the technicians may have their own app. You know, if they're out on the road and they see, you know, there's an event that's in my area, they can accept it, and that'll trigger a different event. So all of a sudden, you keep track of how many of the open items that you have are actually being looked at right now, have actually been assigned to a technician. And finally, you know, every time a work order has been resolved, the issue has been fixed, that's another custom event that's captured, and you can build metrics on this, or all types of analytics. So you can track over time, in this example, how many work orders are being filed over time, how many a day, how many get closed per day, how long are they open, all that type of stuff. And it's very simple to do. You just have to use the API, trigger a very simple event, it gets captured, and then you have all that data that you can then use and analyze later on. Right, Michael talked a bit about user management.
Okay, so I'm gonna go a little more quickly over this stuff. We mentioned that we kind of build a product around this, and I thought it'd be kind of nice if we spent 5 or 10 minutes at the end just to kind of show you what a product like this feels like. It's a little bit, it's similar in many ways to what we've been talking about. It's not exactly, but we have some things that don't exist that we're talking about here, and vice versa. We've got more stuff than what we've talked about here as well. But it gives you a flavor, hopefully, of what an MBAS looks like. So I'm going to go quickly through some of the rest of the pieces here, and then we'll do a little bit of a demo. So user management. All user management means is it gives the custom code or the developer, the mobile cloud service developer, a way to define their own security. And for us, this means that there has to be some sort of role management that is declarative. Role management in Java EE is declarative. You'd like to be able to say, how many people have used Java EE role management and security? A few of you only. Well, so it makes it quite easy to do. You just define the roles, and then you define the APIs and what roles are required for an API to be used. So similarly here, I think role-based security is quite nice, and people like that. But you also like to do programmatic security. In other words, have an API that allows you to ask, well, what kind of roles does this user have in your code that is running on the server side? And then be able to authorize based on that. Okay, I don't know if you saw that happen. I'll do it again. See if you can pick it out. See that? See that? Yeah? Yeah? All right. It's subtle. Just seeing if you're awake. So we just showed storage. Storage showed up in the mobile cloud service. That's no big revelation, right? I think you probably expected some sort of storage to be there. We showed 2 different types of storage because these are the most common. Object storage is an unstructured store. It's essentially key value store. These are everywhere right now. Generally you store blobs. Quite often you store JSON, blobs of JSON. And if you do store JSON, then one of the things you want to do with JSON is be able to query over it. And querying over JSON is helpful because it's not always there for you. And when you have it, you like it. And so that's just kind of a common thing for people to do. The other thing about storage services is they have to group them together. You want to categorize objects into containers or collections of things. That makes it easier to find things because there's not really the querying abilities that you have for relational databases. So this is sort of a standard object storage service. I think most MBASs kind of provide something like this, I think. Relational storage, similarly, there has to be some way to store structured data, relational data. Almost everybody has some kind of relational database in their world, and so you have to be able to access it locally. When I say locally, it kind of means something that's provided by the MCS, the mobile cloud service, or within a related service. So normally this database service is going to be perhaps a little bit lighter than a regular full database. It's not going to give you all the management abilities. You're not going to do backups and stuff perhaps. It'll be more of a cloud feature, a cloud database. And that's what we mean there.
So custom code is another important aspect of any MBAS system. We've talked about API management, and we've talked about a lot of the APIs that the platform is going to provide to you out of the box. Custom code is where you get to inject your own personality into the MBAS. This is where you're going to build up a set of reusable APIs with your own business logic that you can use to build your first app, your second app, your 100th app. You don't want to be doing this over and over again. Custom code can invoke any service that we've talked about so far. It can, whether it's the backend connectors or the geolocation, that's all available to you. What you're going to use your custom code for typically is to aggregate data from all these different backend systems. You're going to shape the data that's in there, transform it. You don't want to just take anything that you're going to your SAP, your Oracle database, your Taleo management system. A lot of the data that comes out of those connectors or those transactions to these backend systems, it's huge data sets, and it's really, really complicated. So custom code is where you whittle that down. You might hit, so when we look at that HR system, to render that page, you don't necessarily want to hit those 5, 6, 7 different backend systems to pull the data back one at a time. Instead, you'll hit your custom code API that you've created and coded to get all the result sets back at once. That set of business logic that you write is going to hit all these backend systems, pull out the data, whittle it down to only what you need, package it up in a nice little JSON object or whatever it is that you're using, and send that back. Your custom code platform should try and support multiple languages. JavaScript seems to be the dominant language of choice right now for mobile development. Java obviously is another popular one. Ruby, the sky's the limit. What your platform offers, the more the better, depending on what you're comfortable with in working with. An important part about custom code, so far we've been talking about the platform, what the platform provides, what it gives to you, what is available. That is all provided by the platform writers themselves. They trust themselves, they're secure. And with an MBAS, since we're talking about this as a service, typically it's running in the cloud, as soon as you introduce the concept of custom code, you have to be very, very careful. You're allowing the user to write their own logic and upload that to your system. You have to be very careful with how you handle that. You really want to sandbox where that code is executing. You don't want them to have access to your own backend systems, your own data, but also other tenants. If it's obviously in the cloud, multi-tenant systems, you don't want someone to be able to write malicious code and access somebody else's data. So it's very important to sandbox the custom code. Quickly with these, so geolocation, probably the mobile features that we're most familiar with. Again, the platform will provide these APIs to you, gloss over some of the native specifics, give you APIs to find out where is the device. So when the request comes in, where is the device that's actually making that request? You should be able to find out where is that device relative to other locations. Because that type of locality, that information, is relevant to all sorts of domains. It can help you with your queries. I think we all do it. It's all second nature. We all expect, if you ask Siri or pull up Google and send out a query to say, what time is my local hardware store, or basically, until what time is the hardware store open? We don't even say local anymore. We expect the first hit to show up in the results to be my local hardware store. We expect it to just know. And it's not just for queries. We talked about the example earlier with push notifications. All different features, all aspects of mobile are going to make use of these different contextual pieces of information. So like we talked about the push notifications going to your local store, it's going to use this contextual information about the geolocation. And when you start mixing it with other other piece of contextual information, you can create even more powerful queries. So I talked about the local hardware store till what time it's open. You want to find a local restaurant. Find me restaurants. You can be that simple. It'll use the geolocation to find local restaurants, and it'll use temporality, the time on your device, to find you ones that are open. So PSR showed up at the very bottom there. That's the type of thing you pretty much expect out of an enterprise MBAS system. It should be fast, reliable, HA. Oh yes, PSR, sorry, thank you, Mike. PSR is probably an Oracle term. I think everyone uses something different. Performance, scalability, and reliability is the acronym that we use. But it's just one of those things that you should have in any platform. Up the top there, Git. You want to be tool agnostic while still supporting the ability to plug them in. So in our case, we're providing plugins for Git, but the tools that you actually use to write your code, you can use anything you want. And it's more important when you talk about custom code as well. For the most part, this is only for the server side. We're not dealing with the client side code here, but when you're writing custom code, you want somewhere to store it and integrate with whatever tools you're using. And of course, above everything else, we want to be secure. We've talked about that throughout the call. Secure at every turn, end-to-end, from client right to the back-end systems. You want it built into the platform, not something that's an afterthought or tacked on later. On the client, OAuth 2 is the big leader these days. Token-based authentication, the tokens can expire. It also supports the use to do third-party login. So not necessarily authenticating against your local IDM provider. You might want to log in using your Facebook account or your Google account. OAuth 2 allows for that. Once you're into the system, your APIs, you want to be able to secure them with role-based security that Mike talked about. So in our HR example, only managers or managers of a certain level maybe are able to access certain pieces of information in that application. And then again, you need to secure your access to the back-end system. So if it's a back-end system that supports OAuth, and again, typical in the B2E scenarios, your employee will have their credentials in a lot of these back-end systems. So when they log in using OAuth 2 on their mobile device, you want to propagate that token and that identity all the way to the back-end system so they get back only the data that they're allowed to see. Other systems may be more generic and don't have the employee information in them. You'll have key certificate management set up within the connector itself so that anytime the connections come through, it's automatically taken care of for you. And obviously we want all the transport protocols to be secured with SSL, whether you're going from client to your platform or platform to the backend systems. So Mike's going to show us a little bit here about what a system like this looks like. We've talked about a lot of the concepts here. It'd be nice. It's nice to see them in practice and give you a better idea.
So you'll see. I'm not sure this mic is on. It's on now. Doesn't sound on. There we go. We have onness. You'll see Welcome Hudson 1541, and that is my get out of jail free card. This is a development version, so if anything goes wrong, we just blame it on the development part of things. Not my fault, right? So I use this UI MCS account, and that's the user. Okay. So the first thing that we look at is this is called a mobile backend as a service. So there's this notion of having a backend. A mobile backend is kind of the abstraction that you use within the mobile cloud service to represent a mobile application. So there's a mobile application sitting on a mobile device, and it talks to a mobile backend within the cloud platform. And the backend, we've called it GOMBE, and this is version 1. Associated with this backend are a number of keys, because these are the way that you get in and call APIs that are part of this backend. The mobile backend can host APIs. We talked about API management. Well, this is kind of the entry into that. And depending on what your authentication mechanism is, we see that if you're using OAuth, then you'll have a consumer key, a client ID with a client secret. And if your prop is not to tell anyone, I'll even show it to you. There. Now you can access this mobile backend because you know the client secret. And you put these two pieces of information in your mobile application, and then that then uses it to go to OAuth to get a token. If you're just using basic auth, you can use that. So that's a backend. And now what we want to do is we want to create an API within this backend. So let's go do that. Here we have the API screen. I've got no custom APIs right now, but these are custom APIs. We've got all the ones that are the core services that we've just been talking to you about. I haven't written any custom code here, but we have user management, storage, notifications, and it goes on, stuff that we recognize here, database, and other things that maybe we don't recognize that we said we offered. Well, these are all things that are in the core cloud platform. They're APIs that pre-exist, and you can look at each one of these and look at the APIs. This is part of your catalog of APIs. So I can click on those and find out those APIs, but we're not doing that right now. We're just going to find out how to create our own API. So I'll create a new API. It just gives me some help. Now, before I do this, what do I want to do? My goal is there's this site called GeoNames, which allows me to specify some information and call a bunch of web service APIs. And it's sort of global. And there's a nice API in there that allows me to pass in a postal code. And that's a kind of a international term for zip code. And returns a bunch of information back about that zip code or postal code. So that's what my API is going to do. I want to pass in the zip code. I want to get back where that zip code, what's the name of the town that zip code refers to. So I'm going to call this the Geo API. You'll see that this is how I invoke it. It gives you the URL that I use to invoke this API. I'll just Geo API. And you'll see at the bottom it says upload a RAML document or drag it here. So in other words, if I have a predefined RAML document that describes my APIs, I can just drag that in and it'll create all the APIs that I need or that are defined in that RAML. The alternative is like what I'm doing, and that is using the designer to create my API. So here it is. I've got this API. I want to define an endpoint. The endpoint is, create a new resource. I'm going to call the endpoint location. Don't need that. I want to define a method for it. Get. And this get now from location is going to take something called a postal code. And it's a string. Furthermore, I want it to return a result. And if I add a response for the successful result, I'll just make it a straight string because I want to return. So in my example data, I'll say it's going to return, I don't know, we're from Ottawa. So we'll just say it's somewhere, so it's recognizable. That's our demo data. That's an example response. I'm going to save this. Okay. Now I want to go back to the other parts that I want to fill in, the security. I can make it anonymous. So remember the Angry Birds application that Jason talked about. You don't actually have to log in or provide credentials for that. It's just something that exists and you just play, right? So from the server or the cloud platform perspective, it's anonymous. The user is just a user. And so you could allow anonymous access. In my case, I want to specify that only users with a given role, in my case, the Mike role. Is anybody here else named Mike? So you might have this role. We'll find out. So you must have the Mike role in order to invoke this API. So any user that has the mic role can invoke this. Otherwise, they'll get an unauthorized. And now, if I go back to the API, I can see, well, let me just open it this way. I can see the implementations. I don't have any. But I can actually test this API. So I specified some sample data in there. The only hook is that I have to specify a user, and I pre-filled in these default credentials. It has to come through a mobile backend, and that's the GeoMB, because remember, that's the way that you call into APIs is through some mobile backend. And the version is 1.0. I'm using OAuth authentication, and Mike Heath has been specified to have the mic role. Therefore, the only thing I need to do to test this is put in some input string. And I can put anything I want because this is just going to be using demo data. It's going to use that somewhere data because there's no implementation. And so it returns somewhere. And that's actually just calling the demo. What if I want to actually call my GeoNames API? Well, to do that, I need a connector. And I did predefine a connector, which is pretty easy to do. This. Just call it a connector. The key part here is that I define the remote URL. This is the API URL to call APIs for GeoNames. And that's pretty much the bulk of it. The other configuration I had to add is GeoNames requires that you pass in a user, and I create a user on this site called Mike Keith, and the country is going to be the US. So every time I make a call to this connector, these two parameters will be passed in along with my call for me automatically. Security, we're not doing any security right now. This web service doesn't require anything special, so I don't need to do anything special. Now I want to test this connector. So to test this connector, I'm using this postal code API as part of the GeoNames part. So I'm going to add that in there. It's called lookup. No, it's called postal code lookup. And who wants to pass me a zip code? Anybody want to volunteer a zip code?
14589.
14589. Okay, so now I'm going to test. Oops, I got to say postal code equals 14589. Now we're just about to find out where this person lives. Let's test it. See if we can talk to this geo service. Well, 200 is good news. This is the information that we got back from Williamson. Is that right? Yeah. Okay, so it's a correct service. Now this is the information that GeoNames is returning us. It's all this, lat long, everything else, plus the place name. We only really want to return the place name. That's what our API returns. This connector returns a bunch of stuff. So our implementation looks like this. I can actually open this guy, the JavaScript for this implementation, and all it's going to do is, this is the API you access it as, Geo API location. The postal code lookup JSON is the resource that we're invoking on the GeoNames connector, the geocon. And I'm just going to basically get the postal codes from that and get the place name from that. This is just transforming the data I'm getting back from the connector and returning just the piece that I want. So, whoops, we don't want to scan. That could throw things into... So now what we do is we want to actually take the implementation and upload it. So let's go back to the APIs. I'm going to invoke this. The implementations, there's no implementations, there's just that mock implementation, the default one. I don't need a JavaScript scaffold. If I was starting from fresh, if I didn't have this pre-created implementation, then I would create a scaffold and start with that. But I'm not going to. I'm just going to upload the one that I got, which is this one that I just showed you. So now it becomes the default implementation, and I can test it. So I'm testing the endpoint. Did I set the application type? I think I did. Well, we'll see in a second. So what was that postal code again? 14589. Now all we should get back this time is Williamson, if it works. If I didn't forget anything. 200 is always good. And there it is, Williamson. So that's my API. I pass in the postal code, I get back Williamson. In the middle, I had a connector that went to the API call, called it, some custom code that took the piece out of there that I wanted to pass back to the mobile device, and then return that to the mobile device. Right? This makes sense. This is the way mobile custom code is going to work. You don't want, if you're doing database queries, for example, you may do a query that has a bunch of data, but then only want a certain piece of that to pass back to the mobile device, because the mobile devices don't like displaying huge, long result sets. So this is just kind of one simple example of creating an API, going through a connector, calling a public service, and coming back. We didn't show anything about the mobile device, but we saw the URL the mobile device calls. That's all that needs to happen, is the mobile device, the app running on the mobile device, calls that API, and that's what they get back. They get back the answer. So summary. Well, I think I got a summary here. Let's see here. I don't have a summary here. Click that one. Do you have a summary there?
Yep. So in summary, yeah, the future is still mobile. We saw devices are becoming more and more ubiquitous. They're going to be more and more out there, more and more different types, and businesses are going to have to adapt. If you don't mobilize your applications, you'll be left behind. It's like in the early 2000s, if you didn't have a web page, it didn't matter. You looked someone up on the web, they didn't have a web page, you ignored them, you went on to the next one. It's the same sort of thing happening with mobile applications. You can't quite approach them the same way as traditional apps. There's a lot of differences. There's a lot more features, functionality that people are expecting out of their mobile apps. API management, it's a start. It's a good example that we saw today with the API management, but that's not enough. You've got to really add all those mobile features in order to really create rich applications. And enterprise companies, they need enterprise-grade MBAS. You can't just have these little systems off the shelf. You've got to have security built in, end-to-end, robust implementations, the whole 9 yards. And analysts, developers, architects, for once, everyone seems to agree that MBAS is really going to be the platform of the future for hosting and running all these mobile applications. Well, I think we're a little bit over time. Thanks everybody for your patience. And
if you have any questions, we'll be around in the area here, and we'll be happy to answer.
Enjoy the rest of
it. Enjoy the conference.
Okay. Good afternoon, everyone. Thanks for coming. My name is Alex Pocelli. I work for Red Hat. And this session, I'll talk a bit a research project that I'm conducting in the Red Hat, how to bring Java EE applications to this microservice world. This is a research that is ongoing. There are still aspects of this research that is, we still do not have answers. But we are feeling confident about what we are getting up to now. So let's give you just before, and probably this title, for I see lots of seasoned engineers here, that anything that's related to auto-magically, you are worried about, because too much magic is not good for anyone, I think. But I will give you the ideas why I spoiled you with these so strong words, and give the background around everything. So we have these trends around microservices, and we also in our team, I work in the Druze and GBPM team, what is called a key team, knowledge is everything team, that we handle knowledge-based technology. And we have such a huge application. Our web tooling is it's more than it's 1.5 million lines of code. All Java EE based application uses CDI, events, and lots of things related to Java EE, JPA, for instance, as well. So, and we have this demand in the market that we need to be in the cloud. And the first question that we did for ourselves is what it means being in the cloud. So we have all these things, all the tooling that we have. Our Druze JBPM tool is basically a web IDE infrastructure available for users that can author stuff, they can build, deploy, and manage everything in this UI, in this what we call workbench. So how you get all these big application, millions and millions of code, and get ready for the cloud? So we, as a team, already have something in the cloud available today that is our servers. Our key server, our JBPM and Druze servers are available as Docker images. You can use, you can play with that, we can execute it. We have the product coming that it has support on it's going to be a container-based solution, and that's fine. But it's just the execution side. But we have all this tooling around, all the workbench that we have is a web application that has 1.5 million of code that we need to scale that in the cloud. So how, and I think most of you have probably similar experience. You go to the conference, see a lot of people talking about microservices. Oh, you have to go microservices. But you get back to your company and say, okay, how to get 1.5 million of code in microservices? This is pretty hard. It's not an easy answer. It's not the sample application that you do that of course, I will do some demo here that's very simple for the concept, but it's not like that you move to the cloud. So you have to figure out how to move to this cloud to get the advantages of this microservice and cloud. So this is basically the idea of the background. My role in the team in this research is now, okay, we have 1.5 million of codes. How do we get to the cloud, ready for the cloud, impacting as less as possible our current code base? The premise is, of course, is that our code base is well-written, modularized code base. So we have several modules. Everything is very independent, and I think Java EE is a good player in that, specifically on the CDI. Dependency injection and the events is a key player. I'll talk about that. That enables your application to be very decoupled. But how to get a good enough application and move to the cloud as a microservice, a Docker container, Kubernetes, all these words around how we move to that. This is my role, and this is the research that I'm working on. So just you probably have seen definitions of microservices, everything. I just take it with Wikipedia. But in the end, we can understand about microservices is simple architecture pattern that you get all what you call in Java world or Maven get modules and get these modules as individual pieces working somewhere in the cloud or independently. So you do not have hard dependency between your modules or big services that you may call, like authentication or authorization. It can be one service, and you have the business logic on the other side, like shop cart, financial processing. You can split areas of your application. This is all about architecture part. So it's not related to technology. It's not related to implementation. Tooling is just an architecture pattern. And the ultimate goal, at least that I see and we see in our team, for going to microservices is basically decouple and compose, decouple what you have and be able to compose the services independently. And the ultimate goal is scale, the scalability of this, that you can have some services that are high load and can get expanded, but once it gets low needs, you can shrink this clustering of services running. So, and it is also important that a goal for Microsoft is not for fast. You not get a faster application running in microservices, because the concept of microservices is distributed across a network, and at least you are adding network latency. Well, if you're so lucky, you just have the latency to handle. But it's a lot the difference that you run in the same process. So it's not for fast, it's not for throughput. Well, you get some improvements of throughput once you can scale better, but it's a different type of throughput. It's not a regular throughput that we measure in regular applications running in a JVM, for instance. Because now we are talking about several JVMs, several parts of application running across multiple containers, or what do you call? What a most common implementation that you go around microservices is always around REST implementation, because you have this notion of language agnostic. So I may create something that other languages or other parts can consume it easily. And now the trend in terms of implementation of microservices are running through containers. Docker has been very important technology for enable this container thing. Back in time, I had friends that are working in the internet business, web companies that has been doing internally containers like style for a while. But I think the nice thing about Docker, they came up with some infrastructure, some API level. They create something that put everything that lots of people are doing put together and solve one single solution, we can say. But a container is just the beginning. And this, I would say that's the easiest part. Because once you have a good application that you can, you have good, clear, different modules that you can package differently and create containers for that, it's okay. But the next step is how to orchestrate that. Because now you're talking about not an application that you deploy in your application server. Now you're talking about how to handle a farm of application service. So how many, I get so many containers around, how do you orchestrate that? This is the orchestration side that nowadays, I think one of the most popular technologies is Kubernetes. But we have other options in the market. People are using different technology, but we believe in that Kubernetes is shining in this space. And all this infrastructure that we are talking about ends up, like or not, it's a PaaS infrastructure that you use some PaaS provider, PaaS-based technology, or you have to create your own tool around PaaS. Because this is what Microsoft will, going to Microsoft, you reach this point that you have to manage your infrastructures as a platform as a service. And this is very complex, very, very complex problem to solve. In a regular problem that we see when you see Microsoft's implementations is that it usually now to communicate across different services, you start to mix business logic with distributed computing logic. Distributed to do the remote invocations, to handle all the things, and this is super complex problem. There are so many research around distributed computing since ever in the computer, and this is still an area that is really, really hard to solve. This is a problem that is really, really hard to solve. And now it's how it relates to the research that we are doing. So if it's so hard to figure out how to do it well, or less bad, I'd say, and you spread these codes that handle network partitions, availability, or complex error handling across all your small microservices distributed somewhere, you bring so many complexity to your existing complex system that there's maybe a way that you can work around this. Maybe some central area that you can delegate to somewhere to help you. And this is why we come to the idea, what if we could get the programming model that we have today, the flexibility, the programming model that we have, very simple, the CDI, for instance, all the dependency injection, all the events. I think the part that I love in CDI is the event, because it helps us really decouple the stuff that you have. But you still have all the flexibility of microservices. If it would be possible to abstract some way the complexity of distributed computing, all these networking issues that you have, how you, and error handling, or how to retry stuff, and keep the values of these, and keep the values of the microservices. So you abstract it, but you keep the values. And this is why this is where we ended with a tool that we are still under research that is called UberFi Cloud Extensions. UberFi Cloud Extensions is very no-intrusive solution that is basically a CDI. I will talk about the architecture of this plugin later. But just before I move on and explain what is this cloud extension thing, I'll give you a warning. It's not for everyone. It's not for everything. Like Microsoft or anything in technology, it can have use cases. It's not for like Facebook or Twitter, because part of their business is the scale, is the size of the thing. But we strongly believe, and this is our case, for 90% of the cases, we can use this solution. And for the other 10, you have to put more thoughts on that and do it more case by case. So this is important. This is not solve all the problems in the world. So now let's talk about JavaE. And I will more focus on during this talk about this 3 different elements, but we know that JavaE is a very mature set of technologies. It's been here forever, and it's really trustworthy, and especially with CDI, it's really amazing how productive you can be, and how easy it is to build applications on top of these technologies. It's rock solid technology. So CDI, JPA, that's I think one of the most popular things that we have in Java. Even applications that are not JavaE applications, they have something related to Java JPA, Hibernate or Eclipse Link, whatever they are using, but someone using the JPA style program. And we have this JMS, that's basically the mechanism that we can have the queues to communicate across multiple services or multiple components across a cluster or whatever. So this is the idea. With these 3 components, we could build a good, reliable solution for cloud. So how we could build. And there is another point. JavaE programming model, the CDI specifically now, doesn't say that you have to pack your application as a monolith. There's nothing related to that. We just pack them because it's easy. Because it's there, you pack it, create a var, and you deploy that. But the programming model associated with CDI, it doesn't imply the distribution model. So the deployment, sorry. So you may decouple this deployment and the programming model. This is very important. Again, about the CDI. CDI is a natural neighbor of good software architecture. Because if done right, you can decouple very well your components, your modules. Even in services, in a general perspective. So if you do it right, you have, with dependency injection plus events, a very modular application, a very loosely coupled application, and one of the goals of technology is a very testable technology solution. So this is what we believe, and this is what we achieve in our project. As I said, we have a 1.5 million code base, millions of code. It's kind of big, but we could achieve these 3 elements just with the programming model CDI. Now, I will show you, talk about a demo that I'll do, that will present to you how a simple Java EE application can have all these elements, the modularity and the loosely coupled. So, I will show now the notes demo. I will switch here. Let's see. It's just blank. What is this? It's not supposed to work. I tested it. Oh, shit. That is not nice. Demo gods is not in my favor. Yeah, but now my screen is black. Everything is black. Yeah. Wow. I have nothing here. Come on. I promise that I have a cool demo to show you. Oh, I have no idea what's happening with my machine. I rebooted. So, yeah, I think that's crashed.
Did your computer?
I don't know, but now I have to restart it. Really? In the middle of presentation? Okay. Yeah, that's happening. Okay. In the meantime, any questions? Yeah, it's a good opportunity for questions. Well, that's all I can do. The one in my personal opinion? Okay. The question is, what's the difference between microservices and SOA? My personal opinion, not much different. But in terms of programming or architecture. But if you think, now I think that the idea of Microsoft is more aligned with this culture around DevOps, and we have new tooling to support this movement to split elements, split the monolith. So you have all these containers that make things more easy to decouple and build stuff. It's way easier. I think this is my perspective on that. Okay. I have just 1 minute. Okay.
Yeah, on splitting the monolith, like we have applications that have a number of different transactions. Well, we be breaking those up into different microservices then. So right now, we deploy one application off to multiple servers, and they have multiple transactions that support.
Mm-hmm. Yeah. In terms of transactions in the cloud, this concept doesn't exist. Once you have all this network, and when you go to Microsoft, this concept doesn't exist. This is also somehow related to this, the previous trend around NoSQL databases. A lot of people asking for, oh, and what about transactions? People would say, well, there's no. So if you have the need for transactions, you have to rethink to go into this strategy.
Eventually consistent.
Yes, eventually consistent. What is funny, because I'm Brazilian, I speak Portuguese, and in Brazil, when this word eventually consistent was translated initially, it was like the eventually word, we have something similar in Portuguese, that means that may or may not happen. It's not like in English that it's eventually, sometime, one point in time, it will happen. But it was fun. We'd go to the conference in Brazil. People, oh, things may not happen. How is that? You're doing computing with may or may not? This is not the way that to do computing. I will mirror and pray. Okay. I got something. Let me get back here.
What are the factors that define when to use a microservice?
Sorry?
What are the points that define when to use microservices?
Well, this is also hard. The industry is trying to figure out when or where to use. But I give you our case. The Druze and GBPM team, we have this Web IDE-based solution that we want to provide in the cloud. It means that there are some aspects of the Web IDE, like the compilation. When you change something in your browser, you need to compile and provide more information for this user. This is a very hard thing to do and doesn't work well in a single machine. You need lots of machines to run that, because I may have 200 users creating rules, creating process. And this is the area that we see clearly that we take advantage of microservices, to have several services, maybe one service per user, one container per user. So it depends. Everything depends on the scenario that you have. Okay. Let me start here. This application here, okay. I created a demo application. It's a note. It's starting. Let me finish this. It's an application that's just a simple notes application that you can write notes, store the notes, or you mail yourself. You can send to mail to someone these notes, or to yourself, of course. Let's get it started. Let's go to this application. I try to use just this screen. I will log into the application.
So how do you secure your microservices?
Wow, there was an awesome talk earlier today that you missed it. There are so many tools around that. I would recommend to you check Keycloak. Keycloak is a project that we have in Red Hat, JBoss, that basically enables you to secure your microservices like that. It's really amazing. It's really amazing technology. And this is a problem that my team or us are not solving. These guys are really doing great. Exactly. Microsoft are running different platforms in different machines, or even different countries, different zones, whatever.
If you have a secure service, it should be another microservice, and it should be securing all these services.
Yep.
So whatever the product that you are using, how it is going to intercept and secure those services.
This is why I recommend you highly check Keycloak. They are solving this problem. They solve this problem. They have a solution for microservices, that how to get the microservices architecture secure. So we have here in the Red Hat, we have this already kind of solved. It's very mature product. It's really nice. I do not know exactly the details, how it works. I know it works. That's all I can tell you. It works. I have one colleague here that kind of understands well the technology. After the session, you can ask him. And we have all the Red Hat booth there, so people that knows a lot about Keycloak and Microsoft security. Back to the demo. I have this simple application that shows empty, but I can create some notes, and I can, my note, save that. Oh, I forgot I need some steps. Yes, of course, I lost my... yes. Otherwise it wouldn't work. Well, I expect it works. Okay, I can save this. I can create many nodes. Save again, refresh. So every time that I get it was stored in the database, is very simple application. Yeah, and you can send it by email to someone. If my network configuration is okay. Okay, mail sent. I have this mock SMTP application that records the emails locally, just so you see. And seeing this application, you can also check in terms of services. It has three main services. You have the front end, you have the back end, split in the mail, the email sending service or module, and the JPA, the persistence side. So you clearly have, get back here, some, okay, clear elements, these modules, clear modules. Today, as my presentation here, this is a container, it's a Docker implementation, it's deployed as a monolith. But it does, as I said, the programming model does imply that it has to be monolith. So let's go to check the code and see how it is structured. Okay. This is the application that I have. It's split in different modules, as should be. We have here the module that handles mail. For that, I have one specific module, just define the interface. You have the send mail here, and you also have an event definition that is mail sent. When the mail is sent, I get the definition. I send an email to the guy that was asking for this service. So I defined the event. But I don't define here in this level, I don't define the implementation. I have another module. This is the way that we split our code base in our team. It's our preference. But we have just one for the implementation itself that does the mail thing that has to be done. Pretty simple. Pretty simple. The same for the persistence. We have the persistent definition here. We have the persistent services. I can get a list of nodes, get nodes, save node, delete node, get node. Pretty simple. And I have in another project, in another module, the definition, the implementation itself. So standard JPA code. Nothing fancy, nothing different. But, and here, of course, the back end of this application written for the UI. Have all these modules, everything is splitted. Just a side comment, we love so much CDI style of programming that we do this on the client side. We develop using Git, and we have a project called in Red Hat called Erai that basically is CDI for browser or Git GWT based application. So you get my demo online in my GitHub account. You can check it, and we think that is really awesome. So you have this application that is pretty standard, and what we introduced, the idea to have this cloud enabled, is just one small change in your code, just this annotation that you call cloud at cloud with a name of the service. This is all the change that you have. So I have here multiple branches. And the branch that I have, one is for cloud enabled. It's pretty simple. It's just add this at cloud. It's all I need. And the infrastructure that we create is pluggable. So if you do not want to use what we have, you can just remove and deploy. It's a monolith as usual. So basically, this is the idea, to have a UBFI cloud enable is get this monolith and split and be able to split it in different services. In our case, it's the persistence, it's the mail and the front end services. And how it works, the cloud CDI extensions, it get the monolith, we add the CDI extension, it gets ready for the cloud. It's simple like that. It's really, really simple. And the architecture is also simple. We have the API definition. That's the only side that you need, depending for in your projects, is at cloud that has just this annotation definition. It could be even, it's possible to not even use that, just using regular configuration files, but it's so easy to have just one annotation that we ended up with this annotation. When we submitted this talk in the beginning of the year, we were using just configuration files. And then we said, oh, all these configuration files could be simplified with just one annotation. Why not? And then we come up with just one annotation. And then to run, to be able to split things, is the CDI extensions. CDI extensions basically does the automatically stuff. That's basically has event observers, event propagation, the publisher, proxy beans, and marshalling. And I visit the code. And the interesting thing about this extension, this plugin to your platform, to your environment, you may have different strategies to implement the deployment. Today, we are going, all the communication over microservices goes through JMS using ActiveMQ. But we are now researching to create a REST-based solution. So you have all the bus around the REST, you keep using the REST, but the programming model in your side will not be changed. Today, we implemented using ActiveMQ, JMS, because it was the simple thing in the beginning. Now we are, after some time of research, we figured out, oh, this may be possible to have different implementations, so we created that. Let's get more what this CDI extension, I want to remove the magic side to you understand, and why I think this is a good solution for most applications. During your application bootstrap of your Java EE, we check if the service is enabled. If we have a configuration, a parameter that defines that this is a service. And we scan for the service names. So we basically check all the add cloud annotation and check that name and collect this information. And we match this with the environment variable that you have in the container. So if they match, this is local service. So it's all fine. But what doesn't match, and we have, like when you distribute, some things will not match, what we do is simply create a proxy bean. We go to CDI, oh, you know, someone is looking for a bean. But instead to provide the real bean, we created this magic proxy bean. And this magic bean is pretty simple. It's just a router. It gets the notification that the original bean should do, and just route it to the proper microservice, and wait for the results. So you can isolate it, handle all the errors, network partition, everything in just one place. That is this communication. Today we get even simpler with ActiveMQ and JMS solution, because I send to a topic or send to a queue, and someone is listening to that and get executed. It's really, really simple. The same happens with events. The events can, just with the add cloud annotation, you can spread it across your cluster. Or if you not give the add cloud annotation your event, it's going to be local. So this was the first mistake that we did during the research. We start to propagate all the events. But there are several events in our application that's just for the module. It's not for everyone. So then we start to realize what the events are more related to microservices, and not related to internal decoupling of such a module. Because when you're talking about compiling something, we have in a point in time that, oh, compilation is done. But we still need to collect information. In this event, there's no a reason to propagate this event in the cloud on the in the other microservice. So we also create the notion of at cloud, and it's done. If there is a at cloud, I capture this event with the CDI notation, and we spread this across the cluster through a topic. Very, very simple. Let's just give you a high-level idea of the code. Here I have the CDI jar that I had mentioned, just add cloud, simple like that. And the default value for local, so it ignores by default. We have the CDI. This is the cloud extension. This is where we intercept and check how your application inject beans or have method events observed and things like that. This is where we collect all the information. Everything here is open source. It's available now on GitHub in my personal account. We're still not merged in the main project, but there's a lot of things. Basically, all this code is adding beans that basically does all the job behind the scenes. Here is how we collect local. We execute locally something that was remote, and all this stuff is here. And you see that there's not much code. So we are pretty happy with just a simple solution that managed to get us ready, not ready, but is a big enabler to go to the cloud on microservices without changing our code base. And I think the nicer thing that we achieved is, let's just to give you an idea about this. This producer here, this is the this is the ActiveMQ that does the job that listen for some topics or some queues and execute code based on what people are executing, some dependency of external service. So it's really, we are very happy with that. And the nice thing about that is that you can just disable that. If you do not want to use, just do not add this in your WAR or your packaging. It's just that, and it's still there. Everything, nothing changes in your application. This is awesome, I think. Just an overview. It's not very readable, but how it works. If it's a remote service or it's a local service. It's a local service. It's pretty obvious. The nodes application go to the persistent query the database, get the data, and return to the nodes application. Simple like that. But if it is a remote service, so if I am in a front-end service and I call the persistent service that I have injected in my application, nothing has changed. But what you do is intercept the method, you send a message to ActiveMQ, say, oh, we have a method call in this service here. And you modify, execute it. This persistent service is notified by the JMS. Something arrived, or it's a topic, or it's a queue. You query the database result, get the results from that, and send it back to the ActiveMQ. And this guy is listening to some topic, or a queue, or a temporary topic, or a temporary queue, and get the results back. So that's how it works for method, and for events it's pretty simple. It's cloud-based event, just throw it, and there is another side that is just listening for what has to be published. Okay, I already showed the code. 510. Okay.
So for microservices, do you need to separate each of these tiers into each of the separate service, or having a complete function and having all these tiers into one service so that it will be distributed easily and there won't be any dependencies?
Yeah, if I got the right questions, but in real world, the microservice, probably you have everything together. Like you're not splitting technology-based functionality. You split the functionality in the business level. So you have JPA in one microservice. Sure, this is just an example.
JPA in one microservice.
Sure.
I want to keep microservices a complete function, small function.
Yes, that is exactly how you have to do. It is how to do microservice, but for this session, I couldn't create several business things, so I ended up splitting Java EE services just to have you an idea of the concept that you can split Java EE applications using hard technology like I showed you, JPA, annotation, all this stuff, and you can split that without problems. But you, in the real world, what you're going to happen is you inject not a persistent, you inject your business service or your business module, whatever you call, and you execute something. When you execute that and goes remotely, called the proper microservice, that you're going to check database locally, check the, everything has to be done in the business logic side and returns the results. But the concept is exactly the same. Okay, now we got the nodes demo. And this is where things can get really dangerous. I will try to show you this nodes application is split in 3 different microservices. For that, I'm using Docker, I'm using Wildfly, and I'm using OpenShift Origin version 3. That is not released yet. I built it from the master, from trunk, and I built local. So many things. It's hard, and it's OpenShift is basically a Kubernetes plus some things that Red Hat implemented on top. So it's just a thin layer on top of Kubernetes. Let me get here the point that I may get something. It was everything done, but now it was prepared, and now it's not. I have to go from scratch. Okay. So you are seeing me preparing the OpenShift development machine. I'm using Vagrant. So it's basically, OpenShift gives us this configuration that's really nice, the Vagrant configuration that sets up the VirtualBox with everything that we need to develop OpenShift-based applications, running locally, of course. It's booting. Well, but another comment that I want to do is using this strategy and this CDI extension, you have different ways to deploy your application. You can deploy your WAR, a fat WAR that we call, everything inside, multiple times. So you have basically one container definition, one Docker image, and you can split the same one across different microservices, define your services, and use the same image, just changing the parameters, the environment variables to the image, and it will work. Or you can go more fancy and more work and deploy it like using Wildfly Swarm, for instance, that is package your application Java main that you consume, that you tell Swarm what service that you are using and you package it. So it's now more an option for you. In this case, in this demo, I used the same WAR deployed multiple times. Okay. You shouldn't be seeing that, but my machine crashed, so. I'll run the thing, that's good. Okay. So now I'm logging up. Okay, now let me get you an idea what I'm doing. I just start Vagrant, I enter to the Vagrant machine. It has now I start OpenShift, that's basically Kubernetes with some UI. And now, and OpenShift has the concept of, on top of Kubernetes, of projects. So I will create one project, and I call this project nodes. And inside nodes, I will deploy a lot of different services. There's going to be front end, mail, and persistence. Okay. Oh, one important part, it was so easy to miss this. I need one, what is it here? I need ActiveMQ running. I didn't create the image for that, so it has to be local. So you are seeing I'm building everything from scratch, for real. And this is scary. Okay. It's running. It's starting. Okay. Now back to my Vagrant. Let's create the new project. OC new project. Oh, let me just, in order to get better machine. OC new project called Notes. And let's visit OpenShift console. Let me log in the console. You see the Notes project. And here I will configure my services. To configure the services, I create a new app. And this app is based on a JSON file. Just before, let me start this. And this JSON file is a template that defines all my application for Kubernetes and OpenShift. Oh, where is it? Okay, here. Wow, it's running. So we see when I create this new app, I created the front end, the mail services, the persistent layer, deployed different containers with different configuration, actually. Let's go to this configuration file just to have a grasp of what it is. All the code, including the configuration files, are available online in my GitHub. Okay, here. Here is how you define your services. Basically, I'm here defining the services as persistent. I route the TCP. I have a route here, route edge is just an example. I didn't change my DNS to answer for that. And here is the interesting part. I defined the deployment configuration. That's basically, I give a name, and I say what's the name of this, and the image. This image is a Docker image that I have now in Docker Hub that you can try. All these you can try yourself. And the variables that I need basically is for this demo application, I need the SMTP to get here the emails. And I have the cloud service names. In this case, for persistence, the name of the persistence. The service is called persistence. And I have the ActiveMQ URL that's defined all the variables here that's reused somewhere. So this is my loopback. So we should be okay. Well, hopefully. It's not that easy once you have everything removed all of a sudden. So I have here the applications. Let's go to the persistent, for instance. Oh, sorry. To the persistent pod. When you're talking about the Kubernetes, pods means the container. Basically, they match 1-1. In OpenShift, in Kubernetes, you can have in one pod multiple containers, but OpenShift is one pod, one container. And that's my image that I built the war with that configurations. We see the log here. The application has started. And what it does in your log is just created some things here, just for an example. I got the Uber-File MQ cloud service running. And the service that this particular deployment is responsible for persistence. I didn't disable the front end, so I can still connect to here, just to see some mess. Oh, sorry. Just to see how it works behind the scenes. Okay. Get my localhost 8080. So I connect to the persistent. I left it enabled the UI because the UI is not tagged as anything. Let me just create here one node and save. So you'll be able to check the log and see. Okay, let's finish here and see here. Okay. The message that it has a node saved, a list nodes, a message like that. It's just for the example. The same we're going to happen for mail. If let me connect it to the front end now. And we see okay, connected. Now my 8080 points to a different place. Yes, there's a message, something has happened. So I lost the connection. Of course, I had now a new server. This is the UI. You see that now I'm connected to the to the front end. When I hit refresh, let's go to the let's go to the console. The console here on the persistent pod logs. What we have here is list nodes. When I hit again, refresh, it has list nodes again. And we have the same war. Let's check the pod from front end. It shouldn't have any list nodes message. So it's delegating to the other Microsoft, another service deployed. And this, if everything goes well, I do the same with email. Mail sent, mail in the box. So after the stress to reboot my machine, everything works. So that's it. Basically what I want to show you in terms of presentation. Let me get back to my slides where they are. And that's it, what I want to show you. Any questions?
So I think in the beginning you started talking about the 1.5 million lines of code. So I think this is really cool. This is the research project. And then the thought is that those 1.5 million are going to use this.
Yes. When you see Workbench, Drew's Workbench running in the cloud, you can make sure that you bet that this is running this technology. Because we cannot afford to change anything or change drastically what we have. So we need to have a quick cloud solution in our tooling. This 1.5 million lines of code has to go to the cloud as is. We cannot change everything. We are changing small areas, but the changes are improvements of the architecture. Is not related with cloud. It's just making sure that like events. We had some events that was not related to the some areas of the code that people were listening for. So we identified such a thing. It could even work in this solution, but what we want is not to expose that particular event with @cloud, so it will not work in those cases. So we are improving the architecture of our platform, but it's a regular refactoring improvement of the platform, not something to go to cloud.
Plan to run these using Wildfly Swarm as your kind of underlying runtime?
Yes, we play with that. We had some initial issues, but we fixed it, and it's pretty good. The result that we got is pretty good. We still, for the demo, we didn't have enough time to prepare that. It's a lot of things to do for this demo, but we are getting some really nice results with Wildfly Swarm. Really nice. And this is something that easy to set up for us as developers. We are very excited in our team to have all these set up. But this is another thing. it doesn't impact our code at all. It's just a packaging. It's just a packaging deployment strategy. That is awesome. More questions? Oh, question. It's my personal. It's Porcelli, Porcelli. GitHub/Porcelli. You just check everything online.
See, a follow-up. Could you talk a little more about the 1.5? So the backdrop is right after you have an application. I'm curious what your use case is, how similar it is, and if you wanted to, if you could expand on like the pain of going from the monolith to the.
Okay. The question is the pain that we are feeling to move 1.5 million to this architecture. There were areas that wasn't that good developed. The architecture was kind of problematic. People depending on details of what it could be a service. One good example in our case is the compilation process. There were people hooking on the compilation event. They shouldn't. There is one proper event in our application that defines when the information is ready to be consumed. Because we do the compilation, but we have to collect the information to feed the browser again to get the autocomplete and things like that. So people, if just stuck with the compilation done, they will not get the data they want. So this was a challenge to figure out why it wasn't working. But it was not that hard using this. This can be an enabler. Because once you, OK, this should be an event, and we try, and it doesn't work in the beginning, and then, oh, no, we are doing wrong here and doing wrong there because we are with wrong dependencies. So again, all the changes that we are doing, and we are doing some changes in the code, but it's to improve the architecture of the application, nothing related to microservices or whatever. I think this is the most important thing. There's another thing that we are changing, and this is more deep change to our go-to-cloud strategy, is regarding our clustering setup. Our cluster setup nowadays is based on Zookeeper. It's using Apache Elix and other tools. And this is an area that we will simplify a lot for Kubernetes and OpenShift, because we have, today, we do our the orchestration by ourselves, what is really hard. I wrote that code and we still have bugs and this is a nightmare. This is what I say. These areas of distributed computing is so complex, it's so hard to get it done right, properly. It's like how you do less bad. With the going to cloud, we'll change some areas because we rely on existing orchestration. That's basically the things that we are changing. But believe it or not, things are going well. It means that we are not changing a lot. We're just improving some areas. Any more questions?
I have two questions. One is the web interface, right? So the web interface that's talking to the EJBs, the traditional EJBs. In the microservices environment, how is that going to work in terms of
Well, very similar, I'd say. In my case here, when I went to to persistent, I left it enabled just to make sure that I could demo and see the right message. If everything was wrong, I could prove that it was somehow working. But when you inject something, we'll figure out what you are injecting. And if it's a cloud, we intercept any method that you execute and we'll delegate. And all the delegation will still comply with the original semantics, because it's another Java EE application server or Swarm running somewhere. So we are not, when we're split microservices, we are not changing the semantics. The semantics are exactly the same.
And one more question on the, generally we have a stateful beans, right? And with microservices being more stateless, how do you?
We are lucky in our platform, we've thought about stateless. Because, well, this is our nature, but you can refactor some areas to use advantage of cache, distributed cache, or things like that for where you need stateful. But if you really need stateful things, maybe package it like a service by itself, a self-contained service, somewhere that you use to keep the state there. And because, as I said, we keep the semantics. So if you put everything together, all the things that need content or is not stateless, if you keep it together, you'll be fine. Any other question? Oh.
For just like an enterprise application with 50 to 100 users, is there any reason to use microservices at all?
Everything depends. In our case, makes a lot of sense to be on microservices. It's not just because of the buzzword. It's to take advantage of this orchestration provided by PaaS solutions like Kubernetes, because we have the compilation phase, what is really intense. We have big code base written in rules. Rules that are really complex, and people hit build, takes forever. You see my machine is screaming, you hear that, and this makes sense. But you are talking about a common line of business, 50, 100, maybe not worth. But it's another thing. With such a solution, if it is a nice, well-written application, you can go to cloud if you need using this mechanism. Because this, for instance, if this type of application you need, I think this is going to be the best fit for them. Because you do not need to worry about distributed computing at all. It's isolated. It's not that simple, but you have a single place to handle all the distributed computing.
Because in that case, it's like you can still take that monolith again, still put it on OpenShift, say replicas equal to, and you pretty much have a highly available service going.
Exactly.
The idea is you're managing all your microservices, infrastructure, and your monolith apps all the same way.
That's true, exactly, yeah. But it doesn't go to Microsoft in a sense. You are just package one container with your monolith and you are good to go.
Yeah, I mean, maybe the phrase is, right, the key question is, how do you scale? And if you can scale your monolith in multiple JVMs and you have multi-tenancy already, maybe microservices makes less sense. Now, if you need to scale...
It depends, because in our case, we are talking about containers. This is not about microservices, it's about containers and orchestration. And this OpenShift does a great job. They scale for you automatically. Depending on demand, how the traffic, you can scale up and down. So if you do it well, your application, your services are done well, like our case for compilation again, we can go up and down in the number of pods without have to manage ourselves this demand. Because go there and have new threads is not enough in our case, because we are talking about the scale, like 200 people compiling code at the same time. We have users that are huge, and they have like 200, is very difficult, but I'd say that 50 people compiling at the same time is very possible in our platform. And small machines by ourselves are going to be crazy. So if you can delegate this to an infrastructure like Kubernetes, it's awesome. And we can do that with our platform. With this thing, plus the Kubernetes and things, it's done for you. You do not have to worry. That's it, I think. Another question? Okay, thank you very much. Mm-hmm.
Right, and make it like a propagate to between like a local, and also sometimes when you have the deployment, you have it like separate between the message queue or whatever.
Mm-hmm.
Is that part of your framework, or is just a standard framework?
You can get just these 3 jars, and it's all you need. You do not need all my stuff.
So in this case, the way the jar is that a project?
Yes, Uberfy is a project from Red Hat that I'm working on. I'm the founders of Uberfy. It's available. It's open source. It's in our account. There is Uberfy account. You can go github.com/Uberfy. It's not there yet. It's in my fork because it's still under research. But you can use just these elements. It doesn't connect with anything around our UBFI framework.
Yeah, so I thought
It's really, really solid. We can even consider in this, because this is a research, we may consider donate this for Dell Spike, for instance.
Yeah,
That is more CDI isolated thing.
I saw some benefit. Do you have any idea to implement that using like different like message queue like Kafka or whatever?
My API is for JMS.
Okay.
I don't care. I just use ActivityQ because it's cool and people use it, and the leader is my friend, so I like it.
That's good because the problem for the scaling on the microservices is like it's not only you scale it, but you need kind of like a reliability. And in this case, the single point of failure most of the time is the message queue. Like the message bus is always failing, and you need to set
Really?
cluster.
Oh, but ActivityQ is pretty powerful on this side. They have the a powerful solution for for a cluster of message queue. But again, this is just an implementation detail of this. We are planning soon, I think beginning of next year, to start a REST implementation. That's going to be pretty standard.
Okay, I will look at it. Okay.
Okay, thank you.
Hey, yeah, so I'm John Klingen. I'm actually the PM for Swarm now.
Oh.
So that's why I was kind of curious if you were going to run this on Swarm.
Yeah.
And from what you mentioned, you had some issues and
Yeah, in the beginning the dependency was
right.
some dependency was throwing that we didn't have a clue what it was, because what it should be was there, and we just skip it for now. But we definitely are looking to use Swarm because it makes sense in our platform. Tools and GBPM makes sense to take advantage of that when we go to the cloud.
Okay, and so some things that we're working on right now is basically doing service discovery within OpenShift. So it sounds like from a service discovery perspective, you're doing it all through JMS, right?
Yes.
Right now. Okay, because what we're doing, at least on OpenShift.
You're relying on server discovery from Kubernetes. Right?
No, not yet. Well, let me refer. I don't know the implementation details. So that's actually Ben Browning that's working on it. But what he does now is he has basically a plugin for JGroups that just uses. Right now, just JGroups is built in, right? For when it's running on OpenShift, he's running a plugin to do. I don't know. It'll plug into Kubernetes somehow. But the other question though is if you're running in. My understanding, again, I've only been at Oracle for Oracle. I came from Oracle to Red Hat 2 months ago.
Wow.
So, the big question is, if we have etcd, should we be storing all of our service discovery, in etcd, and then just using that, and then
But it's what Kubernetes does somehow.
Well, and that's what I don't know. I mean, that's where, from a details perspective, I need to understand that a little bit better. So, at least all the other services, that people write, that aren't running on Swarm, can find the services. And that's what I'm kind of curious about. So.
Yeah, our solution was a research, so we had to go simple in the beginning, and we can evolve. We are pretty happy with the initial results, and this is going to be our strategy to go to cloud, because we cannot afford to write things. I said 1.5 million lines of code, and for our case, it makes total sense to be like that.
So what does that mean for? And I'm not too familiar with your problem domain. What does it mean for you to go to the cloud?
Okay.
Are you offering this up as a software as a service or a platform as a service?
We don't know. It depends of the Red Hat strategy.